hi, everyone. We're going to just wait a couple minutes here to let all the attendees filter in.
Vamos a esperar unos cuantos minutos para permitir que sigan ingresando el restante de los asistentes.
Okay, welcome everyone to today's workshop on the Advanced
Bienvenidos a
Clean
todos
Cars 2
en la
amendments
mesa de
rulemaking.
trabajo en las modificaciones y creación de reglas de los automóviles avanzados limpios.
I'm Belinda Chen, manager of the Low
Soy Belinda
Emission
Chen,
Vehicle Regulation section at CARB.
manager de CARB.
Rebecca, until we get into the Spanish channel, can you let Belinda finish and then you can interpret after she's done?
My apologies.
Yeah, no worries. Thank you.
Okay, well, that brings me to my next point, which is that we have some logistics to discuss. So this workshop is going to have live Spanish interpretation. And so in a few moments, you'll see a globe icon labeled interpretation located at the bottom of the screen.
Escuchar Sorry.
Go ahead. Yeah, why don't you go ahead?
Escuchar la interpretación del idioma número 1 en su junta o webinar, los controles de clic interpretation o interpretación al español. Número 2, de clic en el idioma que usted desea escuchar. Las opciones para esta junta son inglés y español. Número 3, únicamente para escuchar el idioma interpretado, de clic en mute original audio, es decir, mudo al audio original.
So you'll want to select the language that you would like to hear, and options for this meeting are English and Spanish. To hear only the interpreted language, click mute original audio. And we'll have the Spanish slide or the slides available in both English and Spanish. And depending on how your Zoom is configured at the top of your screen, you can either select English slides or Presentación en Español, or if it's been a while since you've updated Zoom, it may just say more options or something like that. And then there's a menu for you to choose from. I'll pause now for our Spanish interpreter.
Nuevamente ahora el intérprete al escuchar interpretación del idioma, las indicaciones son número 1. En su junta webinar, en esos controles, de clic a Interpretation, al español interpretación. Número 2, de clic al idioma que usted desea escuchar. Las opciones para esta sesión son inglés y español. Número 3, para escuchar únicamente el idioma interpretado, de clic a Mute Original Audio. Traducción al español de esto es silencie el audio original.
Okay, so there will be 3 breaks during this workshop for questions and comments. To be added to the speaking queue, please raise your hand. For those joining through Zoom, click Participants, then Raise Hand. For those on the phone, please press *9 to raise your hand. All attendees will remain on mute until called on during the Q&A session. If called on, please unmute yourself using the Zoom mute and unmute button located at the bottom of your Zoom window. For those of you joining us on the phone, please dial *6 to mute and unmute yourself. You can also use the Zoom Q&A box to submit your questions through the workshop. Some of your questions may be answered via the Q&A box, and others will be answered live once we break for Q&A. When you're speaking, please share your name and affiliation before asking your question. If you have any technical challenges, please contact Natalie Reevy at natalie.reevey@arb.ca.gov. As a reminder, meeting materials are available on the website. This workshop is being recorded, and the link will be available at the website listed here on the slide and in the Zoom chat. In addition to your verbal public comments today, written comments may be submitted via the comment docket that is live as of today. Using this public comment form will allow the public to see the comments you have submitted. As a reminder, your comments are part of the public record. If you would like to discuss this rulemaking with us in more detail after this workshop, please do not hesitate to reach out to us using the cleancars@arb.ca.gov email. Okay, so let's turn to the agenda for today's workshop. We'll start with some staff introductions and then cover some background and timeline, then dive into staff proposals and request for input on criteria air pollutant standards, the light-duty greenhouse gas fleet average standards, and the zero-emission vehicle assurance measures. Then we'll wrap up with some next steps and a request for alternatives for the standardized regulatory impact assessment. So starting with some staff introductions, as I said, I'm Belinda Chen. I'm the manager of the Low Emission Vehicle Regulation section. My section handles the greenhouse gas regulation and the LEV4 criteria regulations, and I'm managing the overall rulemaking. Later in the workshop, you'll hear from Anna Wong, who manages the ZEV regulation section, as well as Anna Skadel, who is the lead staff for these amendments. But I first want to introduce you to our outreach and community engagement team, Natalie Reevy and Lisa Kilodikis, who will come on camera and say hi. You may know them already from their work with the ZEV Equity Task Force, but they are helping us with this rulemaking to organize community meetings and communicate our amendments to the general public. One name that is not on here anymore is Mike McCarthy. As you may have heard, after over 30 years working at CARB, Mike moved on to his next chapter this past May. So we'll miss his expertise and guidance, but we wish him all the best. I'm not going to read the names of all the people on the right. These are our brilliant technical staff here who are working on this rulemaking. This is more for your reference, and they'll all be introduced throughout the workshop as their main topics are discussed. So today is our second workshop in our Advanced Clean Cars 2 amendments rulemaking process. Our first workshop was in November of last year. At that time, US EPA had released a proposal for more stringent greenhouse gas and criteria air pollutant standards for the 2027 through 2032 model years. In March of this year, they finalized that proposal, which kicked off our regulatory development in earnest. Today, we're sharing our preliminary proposals, and we will continue to refine those proposals through stakeholder engagement and additional workshops later this year. As I mentioned in our staff introductions, we plan to host a series of in-person community meetings on this effort, and we are working with community partners to plan those events and tailor them to community interests. We'll consider all that feedback that we hear, and in 2025, we'll release our staff report and bring the proposed amendments to the board for consideration. As we shared at our November workshop, as far as the scope of this rulemaking, we are building off of the Advanced Clean Cars 2, or ACC2, regulations that the board adopted in 2022. The most significant piece here is updating the greenhouse gas standards, which the board did not take action on as part of ACC2. So for these amendments, we are considering what the new standards should be in support of California's carbon neutrality goals and considering alignment with EPA where appropriate. For the low emission vehicle regulations, CARB already adopted new criteria standards through the 2035 and subsequent model years. So that means for this effort, we are considering more limited amendments targeted primarily at alignment with EPA, where we can achieve equal or greater emission reductions. We are not revisiting the ZEV stringency adopted in 2022, but we are looking into 2 new ZEV assurance measures to further support the ZEV market. We are also clarifying or making minor revisions to the existing assurance measures as needed to address early implementation issues. So starting with updates on our criteria air pollutant standards, what we call the Low Emission Vehicle 4 or LEV 4 requirements. As we noted during our November workshop last fall, most of our proposals related to our LEV 4 standards were contingent on US EPA's final rule for their Tier 4 criteria emission standards. Now that EPA has finalized, today we will be discussing whether and how to amend our program. We'll start with light-duty exhaust criteria pollutant standards for NMOG plus NOx and particulate matter. Ugo Obieshi will be leading these amendments. Ugo, say hi. For medium-duty chassis certified criteria pollutant standards, Kevin Soti will lead the amendments on the NMOG plus NOx and PM standards, as well as related certification and in-use requirements. You'll see and hear from Kevin in a moment. And then finally, Jason Gordon is our lead staff for evaporative emissions. Jason, come on camera. Jason will lead the amendments for the onboard vapor recovery standard, as well as some other evaporative test procedure changes. And then we'll wrap up this section with some Q&A before moving on to the greenhouse gas section. So Kevin, take it away.
Hi everyone, I'm Kevin Soti, staff here at CARB. I will be presenting our criteria standard proposals. First off, we'll start with the light duty standards. Moving to the next slide. For light duty, manufacturers are required to meet a fleet average standard for NMOG plus NOx for their light duty vehicle fleet for each model year. Current LEV 4 regulations maintain the LEV 3 30 milligram per mile NMOG plus NOx fleet average standard for model year 2026 and beyond, but exclude ZEVs from being counted in the fleet average after model year 2029. This exclusion of ZEVs from the average ensures that the internal combustion engine or ICE fleet gets clean and stays clean in the later model years, even with a growing volume of ZEVs. For EPA's Tier 4 standards, the light-duty NMOG plus NOx fleet average standard is reduced from 30 milligrams per mile to 15 milligrams per mile for model year 2027 to model year 2032. And EPA allows manufacturers to include ZEVs in the fleet average. Although EPA's fleet average has been reduced, EPA still assumes ICE vehicles will continue to emit at or below 30 milligrams per mile, which is consistent with California LEV 4 standards. Therefore, as we indicated at our previous November workshop, now knowing EPA's final standard has not changed much from their proposal, we will not amend the LEV 4 fleet average standard. Next, we will move on to the light-duty NMOG plus NOx certification bins, which manufacturers use to comply with the fleet average standard. For certification, manufacturers are allowed the flexibility to have different NMOG plus NOx emission levels for their different vehicle models, depending on which certification bin standard they choose to certify to. On this slide, we have CARB and EPA certification bin structures for comparison. The top part of this slide shows CARB's ACC2 LEV 4 bins, and the lower part of this slide shows EPA's Tier 4 bins. While both programs phase out bin 125 and bin 160 after model year 2028, as shown in the dashed red boxes for large volume manufacturers, EPA's final rule increases the number of bins available in their light-duty program, as shown in the lower diagram marked by the dotted lines. Only 4 of EPA's new bins align with current ACC2 provisions, bins 15, 25, 40, and 60. CARB is not amending the current Level 4 bin structure for light-duty vehicles, since we have determined it to be sufficient for achieving our emission reduction goals in California. ACC2 prioritizes real-world emission robustness, and our current bin structure will reduce variability between in-use emissions and certification values, as repeatability of emissions testing is more assured. Additionally, our current bin structure is more protective regarding OBD detection thresholds. For these reasons, we are not amending the certification bins for light-duty vehicles. Since we are not making changes to our current Level 4 bin structure, this moves us to our next topic regarding the cleaner CARB provision. So, as we explained in the previous slide, EPA's Tier 4 light-duty program will have more certification bins than CARB's Level 4 light-duty program. On this slide, we will go over the complications the addition of these new bins creates with the cleaner CARB provision, which CARB is proposing to eliminate as part of these amendments. For those not aware, the cleaner CARB provision prohibits manufacturers from certifying vehicles in California at a dirtier emission bin than they certify under EPA. For example, if a vehicle certifies to 35 milligrams per mile for EPA, under the cleaner CARB provision, the same vehicle must certify in California to 35 milligrams per mile or lower. Since we are not changing the current Level 4 bin structure, sorry, I will speak slower for the translation. Since we are not changing the current Level 4 bin structure, this means California will not offer a bin at 35 milligrams per mile, and manufacturers cannot certify to 40 milligrams per mile in California under this provision. Therefore, eliminating this provision provides manufacturers with greater compliance flexibility, especially when differences in available bins exist. We believe the risk is small that manufacturers would certify vehicles substantially dirtier in California than they do federally when they are not able to use ZEVs to meet our fleet average. Additionally, as the population of new ICE vehicles decreases, a manufacturer is less likely to see cost savings from developing a model with 2 different emission control systems. Next, we will shift to our last slide for light duty regarding particulate matter emission standards. On this slide, we will go over ACC2 and EPA's Tier 4 requirements, followed by our proposed changes to the ACC2 PM standard for light-duty vehicles. For ACC2 PM standards, CARB maintains the 1 milligram per mile standard with a full phase-in by model year 2028. Our USO 6 standard starts at 6 milligrams per mile in the interim years and reduces to 3 milligrams per mile by model year 2030. CARB excludes ZEVs from the phase-in. For EPA's Tier 4 standards, they finalized a 0.5 milligram per mile standard for 3 test cycles, reducing from 3 or 6 milligrams per mile depending on the previous Tier 3 requirement. For light-duty vehicles and up to Class 2 light-duty trucks, EPA phases in their new requirement by 20% each year from model year 2027 to model year 2029, with a 40% increase in the final year of the phase-in, and ZEVs can be counted in EPA's phase-in. For Class 3 and 4 light-duty trucks, EPA applies the 0.5 milligram per mile standard starting model year 2030. CARB proposes to harmonize with EPA light-duty PM standards and lower our standard for all test cycles to 0.5 milligrams per mile for model year 2030 and beyond. As EPA standards will be fully phased in at this time, there will not be a phase-in for California standards. This concludes our topics for light-duty vehicle standards. We are now moving to the next part of our criteria fluent standards, which are on medium-duty chassis certified medium-duty vehicles. Similar to light-duty, manufacturers are required to meet a fleet average standard for their medium-duty vehicle fleet for each model year. On this slide, we will go over the medium-duty vehicle, or MDV, NMOC plus NOx fleet average standards for ACC2 and EPA Tier 4, then our proposed changes. For ACC2, we adopted lower NMOC plus NOx fleet average standards, reducing the Class 2B standards to 150 milligrams per mile and the Class 3 standards to 175 milligrams per mile by model year 2030. The California standards exclude sales from being counted in the fleet average. For EPA's Tier 4 rulemaking, they finalized lower NMOC plus NOx fleet average standards and set a combined standard for Class 2B and 3 medium-duty vehicles. The federal standards would reduce to 75 milligrams per mile by model year 2033, and the federal fleet average allows sales to be counted. Additionally, under EPA, all medium-duty vehicles that have a high combined weight rating greater than 22,000 pounds can be chassis certified or engine certified. Based on our analysis, we have determined that EPA standards would be more stringent than CARB in the later model years. Therefore, CARB is proposing that we continue to lower our ICE-only and NMOC plus NOx fleet average standards for model year 2030 and beyond to ensure California's fleet remains equivalent in stringency to what we estimate would be equivalent to EPA's medium-duty fleet average standard if they were to exclude ZEVs from their average. On the next slide, we will go into more detail regarding our ACC2 amendment proposal for the medium-duty fleet average standards. On this graph, we will go over our current ACC2 standards and proposed standards for the fleet average, medium-duty fleet average. The x-axis shows the model year in which the standard applies, and the y-axis shows the NMOC plus NOx emission standard in milligrams per mile. The current ACC2 standards are shown in solid lines for Class 2B and 3 vehicles. The standards reduce from model year 2027 to model year 2030 and remain constant after model year 2030. We are proposing to replace our current separate standards for model year 2030 with combined standards as shown here in the dashed lines. The proposed standards would be further reduced in the later model years. The proposed standards will continue to be an ICE-only fleet average for both medium-duty classes, and the standard would reduce from model year 2030 to model year 2032, with the standard at 130 milligrams per mile and remaining constant afterwards. This ensures the California standards are equivalent to EPA standards and achieves further emissions reductions in California. We are seeking input on whether model year 2030 should remain as separate or combined standards. Now that we have gone over the medium-duty and NMOC plus NOx fleet average standard, we will now go over the medium-duty and NMOC plus NOx certification bins, which manufacturers use to comply with the medium-duty fleet average standard. On this slide, excuse me, on this slide, we will show a comparison of our current ACC2 and NMOC plus NOx certification bins and EPA's Tier 4 certification bins. In California, our current ACC2 requirement is shown on the top diagram. We have separate certification bin standards for Class 2B and 3 vehicles. The highest emitting bins shown by the dashed lines are only available until model year 2028. In the bottom diagram is EPA's Tier 4 certification bin standards. The highest emitting bins in EPA's program, shown in dashed lines, are no longer available in Tier 4, and both Class 2B and 3 vehicles have the same certification bin standards. Although EPA offers more bins, both EPA and CARB offer similar bin structure from 75 to 170 milligrams per mile, with EPA offering more bins under 75 milligrams per mile. Since EPA has a different bin structure from CARB, we are proposing to make changes to better align the two programs in the next slide. On this slide, we will go over proposed medium-duty certification bins that align with EPA from the bin range of 75 to 170 milligrams per mile for both medium-duty classes. These are all the bins we currently have under ACC2. Our current regulations phase out the highest emitting bins ranging from 200 to 400 milligrams per mile after model year 2028. Our proposal will continue to phase out the remaining higher emitting bins ranging from 175 to 230 milligrams per mile after model year 2029. The proposal will simplify the current bin structure, requiring all medium-duty vehicles to certify to the same bin shown here from 75 to 170 milligrams per mile for model year 2030 and beyond. This will align with EPA's bin structure and remove the highest emitting bins. We are seeking input on whether CARB should add a bin lower than 75 milligrams per mile. This concludes our changes to the NMOC plus NOx certification standards for medium-duty vehicles. We will now move to the particulate matter standards for medium-duty. This slide will cover our medium-duty vehicle PM standard proposal. Under ACC2, medium-duty vehicles are required to meet a PM standard on the FTP between 8 to 10 milligrams per mile and 5 to 8 milligrams per mile on their aggressive driving cycles. The PM standard varies depending on the medium-duty class and test cycle. In EPA's Tier 4 rulemaking, they finalized a more stringent PM standard of 0.5 milligrams per mile that phases in from model year 2027 to model year 2031. This standard applies to all medium-duty vehicles on both the FTP and USO 6 test cycle, as well as for the new cold temperature test. Since EPA's PM standard is more stringent than California's standard, CARB's proposal is to reduce the current medium-duty vehicle PM standard to 0.5 milligrams per mile for both the FTP and USO 6 standards starting model year 2031. EPA's PM standard should be fully phased in by model year 2031. Therefore, there will not be a phase-in for CARB. This ensures equivalent stringency to EPA and achieves further PM reductions in California. We will now shift from the PM standard proposal to a medium-duty test procedure change. This slide will go over CARB's USO 6 test cycle proposal for medium-duty vehicles. Current ACC2 regulations require manufacturers to certify to the full USO 6 test cycle for Class 2B and allow low power to weight ratio Class 2B vehicles the option to certify to a partial USO 6. Class 3 vehicles have the option to certify to the unified cycle. Both test cycles are high acceleration and high speed tests, with the USO 6 being the much more aggressive driving cycle. Both test cycles are designed to capture emissions representative of highway driving. In EPA's Tier 4 program, they finalized a test procedure change that requires the full USO 6 test cycle requirement for both Class 2B and 3 medium-duty vehicles that phases in from model year 2027 to model year 2031. EPA eliminated the option for manufacturers to certify to the less stringent partial USO 6 option for Class 2B and the UC test cycle requirement for Class 3 vehicles. Since EPA's Tier 4 requirements differ from ACC2, CARB is proposing that all Class 2B and 3 vehicles certify to the USO 6 test cycle beginning with model year 2030 and allow manufacturers the option to certify to this requirement earlier if they choose. This aligns with EPA and simplifies the certification requirement for chassis certified medium-duty vehicles in California. Next, we will change topics to the medium-duty optional certification requirement. So this is on medium-duty optional engine certification. Currently, ACC2 requires all medium-duty vehicles in Class 2B to chassis certify and allows Class 3 diesel and incomplete gasoline vehicles the option to certify to the heavy-duty engine standards for criteria emissions. Under EPA's Tier 4 rulemaking, they finalized modifications to the optional engine certification pathway that differ from ACC2. In EPA's program, medium-duty vehicles that have a combined weight rating greater than 22,000 pounds have the option to engine certify for criteria emissions. This allows all Class 2B and 3 medium-duty vehicles with a high combined weight rating the option to engine certify if they choose, which differs from the California program. Although CARB and EPA's optional engine certification pathways will differ slightly, CARB is not proposing any changes to the current ACC2 regulations regarding optional engine certification that applies only to Class 3 diesel and incomplete gasoline vehicles. Under both programs, manufacturers have the option to certify to a single certification pathway. We will now move to the last topic for medium duty, which is about the medium duty in use standard. On this slide, we will go over the medium duty moving average window in use standard, also known as the MAH in use standard. Current ACC2 regulations require chassis certified medium duty vehicles with a combined weight rating greater than 14,000 pounds to meet the MAH in use standards. This requires manufacturers to perform PEMS emissions testing on road. Diesel vehicles under the MAH in use requirement must meet a 3-bin MAH standard, and gasoline vehicles must meet a 1-bin MAH standard starting model year 2027. EPA finalized similar in-use requirements for Tier 4. In EPA's program, all chassis certified medium-duty vehicles with a combined weight rating greater than 22,000 pounds are required to comply with the MAH in use standard, similar to California. But EPA standards allow diesel vehicles the option to comply with either a 3-bin MAH standard or a 2-bin MAH standard, and EPA standards start model year 2031. CARB is proposing to change our diesel standard from a 3-bin MAH standard to a 2-bin MAH standard starting model year 2027. CARB is not changing the 1-bin MAH standard for gasoline vehicles or the combined weight rating requirement currently established by ACC2. This will align our regulations with the upcoming proposed amendments to the heavy-duty omnibus standards. This concludes the last topic for medium-duty exhaust emissions. We will now turn to the final topic on criteria pollutant standards, which is evaporative emissions standards. EPA expanded an existing requirement for onboard vapor recovery, also called ORVR, which involves capturing refueling emissions. The ORVR requirement was extended to remaining vehicle classes previously not covered. These newly included vehicle classes are incompletes. A type of vehicle without a truck bed typically sold to a vehicle upfitter, who then customizes the vehicle. EPA's Clean Trucks plan added this requirement for heavy-duty incompletes by model year 2027, and their recent Tier 4 rule extended it to medium-duty incompletes by model year 2030. Our proposal is to align with EPA to apply ORVR for all incompletes starting model year 2030 to encompass EPA's 2 separate phase-ins. And to harmonize with these phase-ins, we plan to allow early certification so manufacturers can certify the same way in California as they would federally. For evaporative emissions, there are a few other minor changes that we are working on. The first change is to align with EPA to allow one added preconditioning drive cycle for medium duty and heavy duty vehicles with fuel tanks greater than 50 gallon. This gives more chance to purge the canisters used on vehicles this size. The second change applies to vehicles using a NERCOS type fuel system, which is normally sealed except when refueling. We plan to extend the NERCOS vehicle preconditioning procedure to all vehicle types, not just PHEVs as it is currently. This will streamline certification by alleviating the need for manufacturers to request special approval when a NERCOS system is used in other types of vehicles. We are also working on a variety of other minor cleanup changes in the evaporative emissions and ORVR emission procedures. The next slides for criteria pollutant standards will go over future workshop topics. One topic that we don't have a proposal for today, but we'll discuss in a future workshop are potential amendments to the Level 4 altitude standards that we adopted back in 2022. We have heard from several manufacturers that meeting these standards on the prescribed timeline for certain test cycles is challenging or creates a substantial test burden. CARB is seeking emissions data and other relevant information specifying why the existing standards cannot be met to inform whether and what type of relief might be warranted. This concludes our proposals and updates regarding the criteria pollutant standards for the Level 4 program. Next, we will move to the question and answer part for this section with Belinda Chen. Thank you.
Thanks, Kevin. So if you have a question, please raise your hand in Zoom. You can either do that by pressing *9 on your phone or using the Zoom button. You can also submit questions through the Zoom Q&A box. So I think we'll start with the questions that are already in the Q&A box, and then we'll go to the hand raisers. And I'll just remind everyone, if you are a hand raiser, to please share your name and affiliation before you ask your question. And also, if any of your questions relate to a particular slide, please include the slide number in your question. So we'll start with the first three questions, which are kind of more light duty related. The first question is, what do you mean by bin? And so that's really the way that our program works. There are certain discrete bins that manufacturers certify a vehicle to. That means that their emission levels are not going to exceed a certain level. And so you don't just say, oh, here's I've measured and this is the number. You have to kind of choose one of those discrete bins. And each bin has sort of specific criteria for different emissions. So I hope that's a pretty general answer, but hopefully that clarifies things a little bit more. The second question is on light duty particulate matter standards. So EPA provides different provisions for small volume manufacturers. Will CARB also align with EPA small volume manufacturer standards? We haven't thought too carefully yet about small volume manufacturers, but I think my expectation is that we would kind of align with EPA if we felt that made sense. So I would say likely, but we haven't really studied it yet. So we would be interested to hear from small volume manufacturers on this. The third question was, can you explain further why you feel the risk of certification to a more polluting bin is limited with the proposed elimination of clean car provisions? And then a comment that they appreciate, this is Will Barrett from American Lung, appreciate the direction to align with federal particulate matter standards and further discussions. So I think the reason we don't think the risk is that high is that I think, like we said in the slide, it's going to be harder for manufacturers to, well, as California's population of ICE vehicles dwindles, the cost effectiveness of making a second system is just going to be probably not very cost effective. So that's one aspect. And then secondly, even if they were to do that, then they're still held to our 30 milligram per mile fleet average. And so I think that is just in itself going to be a challenge if manufacturers were wanting to kind of suddenly change and, kind of decontent any materials. So that's kind of where we landed on this one, but we're happy to discuss that with you further. Kevin, I think I was thinking you could answer the next 3 questions on medium duty. So I'll read them aloud and then Kevin can answer those. The medium duty slides seem to reflect EPA's optional early compliance path for Tier 4. How will CARB incorporate EPA's default compliance path, which phases in the final Tier 4 fleet average in a single step in 2031?
So this was regarding the fleet average, is that correct?
I think so.
Okay, I see. So yeah, I was gonna say for all our other requirements, we are trying to align the phase-in or requirement for CARB by the time EPA's early and default phase-in is set to fully phase in. For the fleet average, from what I'm aware of, was that it would go out to 2033. But as for the fleet average starting in 2031, I guess for default, I think we set our standards, when we set our standards for the fleet average, it was based on California's ZEV population. We looked at what EPA projected for ZEVs, and they projected a smaller amount than California because California has the ACT requirement or Advanced Clean Trucks requirement, which requires medium duty and heavy duty to phase in fully electric vehicles or ZEVs at a certain percentage each model year. And we based our IC fleet average proposal on what the combined standard for California would be. So sorry if that was a little confusing, but in simpler terms, our California standards are a little less stringent than what EPA would project for their federal fleet, IC fleet. And so I think if we were to look at the numbers again, we tried to look where EPA's IC fleet would be in 2031 and where California would be, and we tried to align them as best we could.
Okay, thank you. Next question, Tier 4 medium duty vehicle, is that for diesel only or is there a Tier 4 for gasoline engines?
For which one was this?
This is a question from Thomas Green. And
Medium.
for medium duty Tier 4, does that apply to diesel only or is there a Tier 4 gasoline standard?
Oh, it applies to both diesel and gas.
Okay, and then the last one that we'll do on the Q&A, and then we'll switch to hand raisers, and then I see there's still some more, so we'll switch back. Will CARB's 2-bin MAW NOx standards align with EPA's 2-bin MAW NOx standards?
Yes, for the most part, they will. I believe we're basing it more on California because under the heavy duty program, they reached an agreement with the engine manufacturers called the Clean Trucks Agreement. And under their agreement, California will have slightly different standards for the temperature alignment, I believe. But for the NOx and the pollutant standards, those will be aligned for the 2-bin MAW.
Okay, thank you, Kevin. So we'll switch to some of the hand raisers. So I have Matthew Hensley, Delaney Williams, Ravi, Nadam Polly. Oh, someone's changing. And then there was one more, but it's gone away on, Richard TV. Oh, I guess maybe those first 2 changed their mind. So we'll go start with Ravi Nadam Polly, and then Richard TV will be after that.
Ravi Nadampally, We have unmuted your line and you are free to speak. Please remember to state your name and affiliation.
Ravi Nadampalli from Volvo Cars. It was by mistake. I raised my hand. Thank you.
No problem. Yeah. Richard Tebay, we have unmuted your line and you are free to speak. Please remember to state your name and affiliation.
I must have raised my hand by accident.
Okay.
These are real softballs we're getting. Huh?
Yeah. Vittorio Ricciardi, we have unmuted your line and you are free to speak. Please state your name and affiliation.
Good evening. Can you hear me actually?
Yes.
So yeah, good afternoon, Vittorio Ricciardi from Bugatti Rimac. So my question will be, so EPA is also introducing the possibility from model 2027 until 2029 included of certifying a test group as an interim Tier 4-1, which means allowing the compliance according to the Tier 3 standard, which means, for example, allowing the bin 160 and 125 until model 2029, while keeping the same Tier 4 manufacturer fleet average target for the NMOG plus NOx. So I was wondering if would the ARB consider a similar harmonization, introducing a sort of interim level 4 compliance? Thank you so much.
So I think your question was on this slide, correct?
Yes, please.
Oh, it went away. And so I think, yeah, we were thinking everything would just, we're still trying to figure out the timing of everything. So it's definitely something we can look into and discuss with you further. All right. What? I don't think so.
Sorry, are you? Sorry, are you talking with me? I don't know if my microphone is still on. Unfortunately, I cannot see it.
Yeah, that's okay. Sorry, I was talking to a colleague, but we're definitely still kind of working out some of the details. So I think we'll have to get back to you on this question.
Absolutely. My concern was only about a possibility for example, the low volume test groups that can progressively phase out from a manufacturer fleet and while keeping, the same value that this low volume test group can bring for the customer, while keeping the same fleet average target for the manufacturer and progressively phase out those cars, basically. Thank you so much.
Okay. And then there was a question in the chat about the cleaner car provision for medium duty vehicles. And yet currently that provision applies to both light duty and medium duty vehicles. And I guess maybe the way we put it in our slide presentation, it may seem like it only applies for the light duty vehicles, but I think the proposal would be to eliminate for medium duty as well. Is there one more on the phone?
Yeah,
Okay, let's go to the phone then.
Jackie Yeager, we have unmuted your line and you are free to speak. Please remember to state your name and affiliation.
Yeah, hi, Jackie Yeager at Cummins. Can you hear me?
Yes.
Yeah, just following up to my question that was in the chat. EPA has two compliance pathways for medium duty vehicles to comply with Tier 4, one that they call the early path and one that they call the default path. And the default was in there because of the 4-year lead time requirement. So my question was more around, is CARB considering having both of those compliance pathways offered in their new proposal?
Kevin, do you want to answer or do you want me to answer?
manufacturers can comply with the 75 milligrams per mile standard equivalent in California by 2031.
I'm sorry, it was a little hard to hear you, Kevin, if you were asking a
Apologize.
question.
Yeah, sorry, I had my mic up. Are you saying that, are you asking if manufacturers can comply with the 75 milligram per mile EPA standard in 2031 equivalent in California? Is that the question?
Well, yeah, basically the way that it looks in EPA's final rule that had the 100% phase in of Tier 4 in 2031 being one of the options for medium duty vehicles.
I think that's something we're open to discussing. I think when we put out the workshop, it was more based on the fleet average that went out to 2033. But that of course would mean the most stringent standard happens in 2033. But if manufacturers want to comply earlier, I think we would be open to having an option for early compliance in California.
Okay, yeah, so EPA considered the other fleet average path is what they were calling early compliance. But yeah, it's something we would probably want to discuss with CARB. So thank you.
Okay, thank you for your question.
Okay, it looks like we'll go back to the chat. Will this is a question from Thomas Green. Will these changes to ACC only affect the manufacturers, or will the buyers / businesses need to comply with some parts of this? Yeah, so generally these sets of standards apply only to the manufacturers of the vehicles. Obviously consumers will purchase them, but they don't necessarily know what the emission certification levels are of the vehicles that they purchase. And then the next question is from Luke Spinolo. CARB has proposed in the March 20th, 2024 heavy duty omnibus workshop to align heavy duty spark ignition certification standards with EPA in 2027 model year, which would mean a heavy duty spark engine standard of 35 milligrams NOx per horsepower hour on FTP and SET duty cycles. Does it make sense for the current MDV in use 1 bin mall spark ignition standard of 20 milligrams per horsepower hour to not also be adjusted, which is on slide 25? Otherwise, medium duty spark ignition engines will have a more stringent in-use NOx standard than heavy duty spark ignition engine certification standards. Kevin, do you want to answer this?
Yeah, give me 1 second. So the question was regarding whether we would need to adjust the 1 bin mall as EPA has adjusted their spark ignited auto bin standard. Is that correct?
Yes.
Currently, we are working with our heavy duty section to determine what they'll finalize. I think for at least our data, we had shown in the previous rulemaking that vehicles could meet the 1 bin mall standard as they are now, that is at the 0.02 NOx with the current conformity factor. I believe we are open to discussing this further, but we do want to continue to evaluate emissions for gasoline vehicles. And also, I know heavy duty is not going to remove their standards, so they'll still test on the mall and require manufacturers to meet on a high load cycle. So once they finalize their regs, we'll have to determine what's best for the chassis certified vehicles. Belinda, is there anything you want to add?
No, I think our current proposal is, yeah, not to change it, but we are open to your comments. Okay, so it sounds like no more questions on criteria. So we'll move on now to the greenhouse gas section.
Great, thanks, Belinda. So moving on to our light duty greenhouse gas standards, my name is Anna Scodell, and I'm a staff person here in the Advanced Clean Cars branch at CARB, helping to lead this portion of the rulemaking, and I'm going to introduce some of my colleagues who are also helping out here. We've got Cody Livingston, if you can come on camera and say hi. You've also already heard from him as your MC for the phone calls today.
Hello.
We've got Xiaoli Hu helping with, and Cody's helping with a lot of our modeling and data analysis. We've got Xiaoli Hu. Xiaoli, if you want to come on and say hi, there she is. Also helping with lots of data analysis and number crunching. And then we've got two folks working on motor vehicle air conditioning, Tao Zhen. Come on and say hello. There's Tao, and Sing Ju. Can you come on and say hello? All right. So that's the light duty greenhouse gas team. So I'm now going to walk you through our proposal today. So we're going to start with some updates on this topic since our November 2023 workshop and some background information. I'll then go over our proposal for the California light duty fleet average greenhouse gas standards. And as you can see on this slide, there's several different topics that we'll go through under that proposal. I'll also provide an update on some staff analysis on real world emissions that's helping to inform our estimates of the benefits of our programs. And then just like with criteria, we'll open it up for another round of questions and answers. Okay, so starting this discussion with some background and sort of setting the lay of the land here in California as we think about developing our proposed greenhouse gas standards. The chart on the left here shows our projected share of light duty vehicle sales by technology type. And as you can see, as our Advanced Clean Cars 2 zero emission vehicle regulation phases in, we see that our ZEV sales increase and our internal combustion engine vehicle or ICE sales decrease. And then beginning in the 2035 model year, the only new internal combustion engines sold in California will be those that are on plug-in hybrid electric vehicles. So that's what we see as far as our technology types over this time frame. Also during this time frame, our existing greenhouse gas standard, which applies to new light duty vehicles, is flatlined starting in the 2025 model year. So we have a flatline greenhouse gas standard, and we have an endpoint in 2035 of no new internal combustion engine vehicle sales. So as we're thinking about developing an updated greenhouse gas standard, we're trying to figure out how to get from point A to point B in a way that supports our climate goals. So the big question we started with and we're going to talk through today is what policy design best supports those goals. So to start thinking through that question, we wanted to take a look at what EPA did in their final rule, which they finalized in March. So just as Kevin covered a lot of EPA's rulemaking on criteria, they also updated their greenhouse gas standards. So I'm going to talk through a little bit of what they did as some context for our thinking. So EPA's greenhouse gas standard is based on a sales weighted average of a manufacturer's sales, including their zero emission vehicles. And the way this works is that manufacturers earn credits when the vehicle is above the standard, which is measured in grams of carbon dioxide per mile, and they accrue debits when their fleet is below the standard, or sorry, emits at higher levels than the standard. So EPA's rule establishes more stringent standards, ramping up from 2027 through the 2032 model year and then flatlining. And these standards are projected to result in a fleet-wide average for national vehicles of 85 grams per mile of CO2 in 2032. And just for some comparison, our flatline standards we're estimating to be at about 171. So certainly standards are quite a bit lower. Both the existing California standard and EPA's standards use what we call footprint curves to help implement the stringency. And what those do are establish different emission targets depending on the size of the vehicle. Both programs also have two separate footprint curves, one for cars and one for trucks, with trucks generally being allowed to emit at higher levels. So in EPA's rule, they've maintained those separate car and truck curves, but they made the slopes flatter, and they also narrowed the gap between the car and truck curves. And these changes basically have the effect of reducing the variation in the emissions that are allowed between smaller and larger, or lighter and heavier vehicles. Two other pieces of the program to mention. CARB's program, our current GHG program, accounts for incremental upstream emissions from electric operation of zero-emission vehicles and plug-in hybrids, which basically means that these values do contribute to the greenhouse gas emissions of a manufacturer's fleet in assessing compliance. Under EPA's program, ZEVs and the electric share of a plug-in hybrid's driving count at 0 grams per mile. So that's for compliance purposes, those aren't counted as emitting. Both programs provide for technology-specific credits for manufacturers to reduce emissions in ways that might not be reflected on the standard test cycle. And what EPA did in their rulemaking is phased those down by quite a bit to much lower levels than what's currently available in CARB's program or EPA's previous program. And this is helping ensure that manufacturers are reducing the tailpipe emissions from those vehicles. Okay, so let's take a look at some numbers here, starting with what these standards look like in the California context. So this first line on the top here is the California flatline standard, and as I mentioned, that's about 171 grams per mile. This next line here is EPA's standard, adjusted for the California fleet mix. And so you can see that EPA's standard is clearly numerically more stringent than California's. However, when we add in California's Advanced Clean Cars to ZEV regulation, and we take what we think ICE vehicles will be emitting based on EPA standards, we actually expect manufacturers to exceed what would be required of them to meet the EPA standard if we were to adopt it as is for California. And this result isn't necessarily surprising, given that the number of zero-emission vehicles needed to meet our ZEV regulation is greater than any likely compliance pathway that EPA estimated manufacturers might take to meet the EPA standard. But this means that harmonizing with EPA's stringency in California wouldn't necessarily deliver additional emission reductions here. And in fact, under a fleet average standard that includes zero-emission vehicles, it's possible that ICE vehicle emissions will increase as more ZEVs enter the fleet. And what this chart shows here is the theoretical maximum amount of emissions that ICE vehicles could have as ZEV shares go up in California. And we shared a chart like this in our November workshop, and it shows a worst case scenario, and that's certainly not the amount of backsliding that we would expect to occur. But we are concerned about smaller increases in internal combustion engine vehicle emissions that could occur with a fleet average standard that includes ZEVs, and those increases would be counter to our climate goals. So I want to drill down a little bit more into the ways we might see ICE vehicle emissions increase. Of course, one reason is as manufacturers convert relatively lower emitting models to zero emission platforms, the remaining ICE fleet could have higher emissions. And this is something we understand this could occur, and this is, that piece is pretty broadly consistent with our policy goals. But we could also see ICE vehicles have emissions increases from deliberate decontenting of individual vehicles, dropping of lower emitting variants, or recalibrating vehicles to focus on performance improvement rather than emissions reductions. And those are the contributors to backsliding that we're really concerned about and want to make sure that we're addressing through this rulemaking. One other issue we've been thinking about in developing these standards, in addition to how we can prevent backsliding, is what kinds of emissions reductions are appropriate from the internal combustion engine fleet. Zero emission technologies certainly remain our central focus when we look at our programs as a whole, but we know that there are commercially available, technically feasible technologies that manufacturers could use to help make sure that the ICE fleet is also continuing to support our climate and emission reduction goals. And over the past few years, as manufacturers have shifted investments to ZEVs, they've not adopted some of these previously developed and deployed technologies at the same rate that we expected. So that's technologies like lightweighting, which involves using advanced materials to reduce vehicle mass, advanced engine technologies like downsizing or turbocharging, or increased hybridization, ranging from mild hybrids to stronger hybrids that feature higher levels of all-electric range. So looking at these technologies and thinking about our standards, our goal here is to find the right balance between continuing to focus investment on zero-emission vehicles, while also making sure that manufacturers continue to implement these proven technologies. Okay, so putting all those pieces together and thinking about our policy design, we're proposing an ICE-only fleet average standard. We think that this is the best way to prevent that backsliding from the ICE fleet and promote those modest ICE improvements. And as Kevin mentioned before, for our NMOG plus NOx fleet average standard, this is very consistent with what we did in our criteria standards with removing ZEVs from the fleet average. So to provide appropriate lead time, here we're proposing to begin this new ICE-only standard in the 2030 model year. And as you can see here, we're not proposing a stringency today. We're still considering what the stringency should be to help the ICE fleet move from 2030 to 2035, when the only new vehicles subject to this standard would be plug-in hybrid electric vehicles. So we're seeking input on that topic. And to clarify, we're not looking for ICE vehicles to slash emissions year over year, but we do want to identify an appropriate stringency that limits backsliding and relies on those existing technologies to deliver those modest improvements that have been left on the table. We're also looking for input on what an appropriate footprint curve would look like for an ICE-only fleet. As we noted above, EPA flattened their footprint curves and also narrowed the gap between the car and truck curves to help ensure meaningful emission control, even if consumers continue to purchase larger vehicles. And so we're interested in feedback on what our curves should look like with an ICE-only standard. Okay, moving now to the topic of crediting of plug-in hybrid electric vehicles. So removing ZEVs from the fleet average means that, just as we did on our criteria standards, we would not be accounting for plug-in hybrid EVMT under the standard, or electric vehicle miles traveled. So I want to talk a little bit about how this changes from our existing program to this proposal. What I'm going to say here is very much a simplification, but it's just to help illustrate how this would work under the proposal. So under our existing greenhouse gas program, which includes internal combustion engine vehicles, plug-in hybrids, and zero-emission vehicles in the fleet average, we assign those plug-in hybrids lower greenhouse gas emissions, assuming that some portion of their operational time will occur when that vehicle is being powered primarily using grid electricity. And we can think of this as the EVMT. To account for that EVMT, the program basically uses what's known as a fleet utility factor to assign an EVMT share based on that plug-in hybrid's all-electric range. And in general, vehicles with a longer all-electric range have a greater EVMT share. So this is a bit of a simplification, but just to kind of see it in an equation format, to figure out a plug-in hybrid's greenhouse gas emissions under the existing program, we take their charge sustaining emissions, which is basically their gasoline operation, and discount it by that EVMT share that we figured out with the fleet utility factor. Okay, so that's the existing program. Let's now turn to how we're revising this with our proposal. So with an ICE-only fleet average standard, we want to account for the combustion emissions from vehicles. Rather than discounting plug-in hybrids by some EVMT share, we want to regulate the internal combustion engine component of the vehicle. And for this reason, we are crediting plug-in hybrids based on their emissions when operating on gasoline and not on that grid electricity. That's those charge sustaining emissions that I mentioned. This eliminates the need for a fleet utility factor because we're not estimating that EVMT share, and it's consistent with how plug-in hybrids are credited under CARB's LEV4 criteria standards, which, as I mentioned, also don't include ZEVs in the fleet average. I also just want to mention, I had talked about the upstream emissions on the slide explaining EPA's program. This approach of moving zero emission vehicles and the plug-in hybrid EVMT out of the fleet average standard means that we would no longer be accounting for those incremental upstream GHG emissions in our compliance for the GHG standards. As I mentioned, we're developing our greenhouse gas standard that eventually will apply to, by 2035, the only vehicles subject to this standard will be plug-in hybrids. And so in addition to seeking input on the overall stringency, we're also specifically seeking input on future plug-in hybrid charge sustaining emissions rates and what an appropriate stringency might be for those vehicles. Okay, so I've just covered the main components of our proposal. I'll now talk about a couple other provisions and flexibilities that we are proposing. So first, I want to talk concern that we have heard from manufacturers about an ICE-only standard, which is, what do we do about internal combustion engine emissions increases that might look like backsliding, but are really the result of a manufacturer having a dwindling number of ICE models as they expand their zero emission offerings? So in thinking through this issue, I do want to clarify that our proposal is still to have separate car and truck footprint-based curves. So it's not a matter of whether the last to transition vehicles are smaller or larger, or cars or trucks. The issue is if the remaining vehicles are biased towards the higher emitting variants that are above the standard, rather than having a balance of lower and higher emitting variants to meet the fleet average targets. So we have an imaginary passenger car fleet here to help illustrate this issue. And let's take a look at what that looks like before this manufacturer introduces any zero emission vehicles. And I want to stress that these are all purely hypothetical numbers just to illustrate this issue and one of our potential solutions. So let's imagine this manufacturer is subject to an ICE-only standard. You can see here this dotted black line is their footprint curve. That's the standard. And they have some vehicles that are above that footprint curve, some vehicles that are below the footprint curve. And we see that overall, on average, they are exactly matching this hypothetical target of 218 grams per mile. Now let's imagine this manufacturer invests heavily in zero emission vehicles. As more and more models become zero emission and their conventional ICE volumes decrease, we can see that their last vehicles in the ICE fleet could be these higher emitting models. And you see their vehicles here that are still internal combustion engine are clustered above the footprint curve. And we see here in this, again, purely hypothetical scenario, their ICE vehicle emissions have increased to above 300 grams per mile. So this looks like backsliding. This would not be complying with an ICE-only fleet average standard. So what can we do to address this issue? One option I do want to emphasize is under the existing program, manufacturers can bank credits that they've generated in the earlier years of the program, or they can obtain credits through trading. And we think that this would help address this issue, and we're planning to continue that flexibility. I also want to mention that even as California approaches our 2035 100% ZEV sales requirement, manufacturers will still be permitted to sell large ICE volumes nationwide. And assuming that they're offering a variety of models at the national level, we think that that will provide some flexibility for them to still bring lower emitting ICE models into California, even as their ZEV share increases. But certainly recognizing that this could be an issue, particularly for manufacturers that plan to electrify most or all of their platforms, we're thinking about new flexibilities to help address this. And most notably, we're thinking about a mechanism to reward manufacturers that are truly ahead of the game on zero emission vehicles by allowing them to transfer ZEVs that would have earned excess ZEV value in the ZEV regulation back into their ICE-only GHG fleet average. So if we take a last look at this example, we see that if the manufacturer is able to count a certain subset of their zero-emission vehicles towards their greenhouse gas requirement, rather than their zero-emission vehicle regulation requirement, they are able to comply with this ICE-only fleet average standard. So this is something we're certainly seeking input on, as well as other ideas on how to ensure that manufacturers can manage a shrinking number of ICE vehicle test groups without sacrificing emissions reductions. Okay. So touching now on another topic on the treatment of credit banks from the Advanced Clean Cars 1 program. So as I mentioned above, in this proposal, we're not talking about requiring manufacturers to newly develop technologies to meet the standards, but we still believe some lead time is appropriate to transition to an ICE-only fleet average. And for that reason, as I said, we're proposing to update this stringency beginning in the 2030 model year. Then if we look at the intervening years between 2025 and 2029, our greenhouse gas standard remains flat. And in this very colorful chart here, that's that top line, our flatlined fleet average standard. The blue line here that is sort of flat and then goes down shows what manufacturers would be expected to meet under EPA's rule. And we expect manufacturers that remain on track to meet the federal standards will very likely have fleets that would significantly overcomply with our flatline standards, especially as they comply with our ZEV regulation and introduce more zero-emission vehicles. And this overcompliance could result in excessive credit banks for a lot of manufacturers heading into the 2030 program. And that really makes it harder for us to establish a meaningful standard for California. So to avoid this credit windfall and help ensure a stable trajectory of continued reductions, even in the presence of our flatline standards, what we're proposing is to retire all ACC1 credits in 2030 that were earned from performance below CARB standard, but above what compliance with federal equivalent standards would require. And that's this top area of the chart with polka dots. What manufacturers would be allowed to do is carry forward credits that they earn for performance that exceeds what they would be required to do under a federal equivalent standard. And that's shown in this green area with the checkerboard pattern here. What this all, and then, will be required to do under the federal equivalent standard and then up to their hypothetical performance, which is this purple line here at the bottom. What this all means is that in order for manufacturers to enter the 2030 program with credit banks, their combined zero emission and ICE vehicle fleet greenhouse gas performance would need to outperform EPA's standards as adjusted for the California fleet mix. And given the higher ZEV sales here in California, we expect that many manufacturers would already be on track to do this, especially if they continue their ICE vehicle fleet on a path of lower emissions. Okay, turning now to off-cycle credits. So as we stated in our comment letter to EPA when they came out with their proposed rulemaking last year, our comments were that a lot of off-cycle technologies do offer real benefits, but these benefits are generally small in magnitude, and this program is really resource intensive to implement. In EPA's final rule, they are excluding zero-emission vehicles from eligibility for off-cycle credits starting in the 2027 model year. And then they're ramping down the maximum amount of off-cycle credits available for internal combustion engine vehicles with a full phase out by the 2033 model year. So we're proposing to likewise phase out the off-cycle credit program, but for now, we're not proposing a phase out schedule. We're going to consider what that schedule should look like as we develop our stringency and think about what level of flexibility is warranted. Okay, I'm now going to talk about our proposals for motor vehicle air conditioning credits, starting with leakage. So under EPA and CARB's current programs, manufacturers can earn credits for using refrigerants with lower global warming potential, or GWP, and designing their systems to minimize refrigerant leakage. Because of new federal requirements that will make the use of those low GWP refrigerants mandatory, EPA is phasing down the amount of air conditioning leakage credits that manufacturers can earn. However, in recognizing that there are still benefits to be gained from using even lower GWP refrigerants and designing low leak systems, EPA is retaining a smaller leakage credit for the use of these lower emitting refrigerants. So we agree with EPA's direction, and we expect that this retained credit value in EPA's program will still provide meaningful incentives to backstop reversion to higher leak technologies. So for our program, we're proposing to take a similar approach to EPA by eliminating the majority of the leakage credits available, but still retaining some amount. What we are considering is a slight variation from EPA's crediting formula, and we're evaluating what specific values we'll use to calculate the available leakage credit with a goal of further incentivizing low leak designs. And because we're proposing to remove ZEVs from the greenhouse gas fleet average standard, we're also considering what mechanisms we need to put in place to help make sure that those vehicles also maintain low leak designs. Okay, and then the last bucket of technology-specific credits in the greenhouse gas program is motor vehicle air conditioning efficiency credits. So these credits incentivize manufacturers to design and use air conditioning systems that reduce the energy use needed to power the system and therefore reduce greenhouse gas emissions from fuel consumption. In their final rule, EPA is maintaining these credits, but they're limiting eligibility only to those vehicles with internal combustion engines. And in their rulemaking, EPA noted that because zero-emission vehicles do not have engine emissions, improving air conditioning efficiency isn't necessary to further decrease vehicle engine emissions, and actually providing those vehicles with these credits generates negative emissions values, which is not reflective of reality. So we agree with EPA's reasoning, and with an ICE-only fleet average standard, we would likewise restrict air conditioning efficiency credits to internal combustion engine vehicles and plug-in hybrids beginning in 2030. Okay, and then the last piece of the proposal here is the definition of medium-duty passenger vehicles. So these vehicles are subject to CARB and EPA's light-duty greenhouse gas standards. In their rulemaking, EPA expanded their definition of these vehicles to better capture some passenger vehicles that fall outside the existing definition. These modifications include increasing the weight threshold to include heavier vehicles, increasing the cargo area threshold, and adding a work factor threshold to better define these vehicles. And what this does is include more vehicles than under the current definition, meaning that some vehicles will be pulled out of EPA's out of EPA's medium duty greenhouse gas program and into the more stringent light duty program. And in their rulemaking, EPA stated that one of their goals here was to help address new passenger battery electric vehicles that might be heavy enough to fall outside the current medium-duty passenger vehicle definition, but really are passenger vehicles. And we agree and we're proposing to align with this expanded definition in 2030. But I want to mention that because we're proposing to exclude zero-emission vehicles from the light-duty fleet average, we expect the overall impact on the number of vehicles that would be newly subject to these standards to be relatively small. Okay, so thank you for bearing with me on that. We have a few more slides on the light-duty greenhouse gas, and then we'll get to your questions very soon. So what I've just covered are the core elements of our regulatory proposal, but I want to take a few minutes to talk about another issue that we have been exploring as part of this rulemaking, and that's trying to gain a better understanding of real-world emissions, which we know are often higher than certification values. As we mentioned in our November workshop, real-world data suggests that this phenomenon is particularly true for plug-in hybrids and that we may often be overstating the emission benefits of plug-in hybrid electric vehicles. Our main goal here is to understand these trends and account for them in our estimation of the emission benefits of our programs. But we would also consider regulatory approaches to help ensure certification values are more representative of real-world results if it was warranted. So we've been digging into this topic with a few key questions in mind, including what are the real-world emissions of plug-in hybrids relative to their certification values? How does that relationship compare to other vehicle technologies? And are there readily available explanations for those discrepancies? So I'll just share some of our results here. One key finding from this work is that while almost all real-world emissions exceed certification values, this is disproportionately true for plug-in hybrid electric vehicles. So we've continued to analyze data from the Bureau of Automotive Repair, or BAR, which is an ever-growing data set of real-world emissions from vehicles in California. So for this analysis, we took our BAR data, we removed models from the data set that didn't have a big enough sample size, and compared their certification values to their real-world emissions. So let's look at some of the results. Starting with our internal combustion engine vehicle models. So what you have here on this chart, each bubble represents one model scaled by its count in our data set. And again, the x-axis here is certification values, and the y-axis is the real-world emissions. So if these values were identical, we would have a straight diagonal line here with a slope of 1. But here we can see that for the internal combustion engine vehicles, they have higher real-world emissions than what they certify to, with a slope of 1.4. And so those real-world emissions are certainly higher than the certification values, but that discrepancy is generally consistent with adjustments that EPA already applies based on 5-cycle testing to generate values for the fuel economy label and for estimation of in-use benefits. So that sort of aligns with what we would expect. So now let's turn to our plug-in hybrid electric vehicle models. Here we see a slope of 2.1, meaning that the real-world emissions from plug-in hybrids are more than double their certification values. And those certification values are heavily affected by that fleet utility factor that I mentioned earlier. So we see that they're exceeding their certification values by a much greater magnitude than internal combustion engine vehicles. We also looked at conventional hybrids since we thought that might be sort of the most appropriate comparison for a plug-in hybrid. And we actually saw that conventional hybrids also have worse performance relative to their certification values, even compared to internal combustion engine vehicles. That was concerning, but we do see that they're closer to the ICE vehicle trend than the plug-in hybrid trend. So we're looking into this hybrid question to understand whether this is the result of how hybrids are driven in the real world compared to the test cycles. And we think there's more work to do here on understanding these differences, assigning emissions benefits, and thinking through policy solutions. But of course, we also wanted to do a little more digging into the plug-in hybrid vehicles. So focusing again on those vehicles, we're continuing to look into why we see this trend of the real-world emissions differing so dramatically from the certification values. This as I said, this is a growing data set, and it continues to show the same story that plug-in hybrid owners are not utilizing the electric capability of their vehicle as much as the fleet utility factor estimates. And so we've been taking a closer look at some of the models in our data set to try to understand why. And one critique that we've heard of the BAR data is that maybe the plug-in hybrid data that's in there is influenced by used vehicles that are newly brought to California, and that maybe folks who were driving them into the state were traveling a long distance and weren't charging during that move to the state. So we looked at our data set, we separated out the vehicles that were already in state as registration renewals and compared those to those that were being initially registered from out of state. And as you can see from this graph, the relationship between in-use emission levels and certification values is nearly identical for out-of-state vehicles versus in-state vehicles, indicating to us that there's not any significant bias from those out-of-state vehicles. One other notion we have heard to help explain these high plug-in hybrid emissions is that maybe the people who buy plug-in hybrids in California are doing so just to gain access to high occupancy vehicle or carpool lanes, and maybe they aren't really motivated to charge their cars. So we looked at those real-world emissions compared to the certification values for plug-in hybrids that have those HOV stickers versus ones that don't. And we see that there is really no distinct difference in these trends. If we were to see a difference, it actually looks like the vehicles without the sticker are in fact emitting at slightly higher rates relative to their certification values than the vehicles that do have that sticker. And we share this just as another data point to highlight how difficult it is to predict plug-in hybrid vehicle driver behavior and therefore accurately project plug-in hybrid real-world emissions. So as I mentioned before, our proposed ICE-only greenhouse gas fleet average standard would be crediting plug-in hybrids based solely on their charge sustaining emissions. So we would no longer be estimating that EVMT share for compliance purposes, but we are continuing to assess these issues to quantify the benefits of our programs and think through any potential regulatory mechanisms to better reflect real-world emissions. And so with that, we've talked through the greenhouse gas proposal, just concluded an update on some of that data analysis we've been doing on real world emissions, and we'll now open it up for Q&A.
All right, thank you, Anna. I think we'll start with the questions that are in the Q&A box, and then I see people are raising their hands. So just a reminder that if you'd like to ask a question live, go ahead and raise your hand in Zoom using the raise hand feature under participants, or you could use *9 on your phone. And then you can also submit a written question through the Q&A box. And another reminder, if you are speaking, please state your name and affiliation, as well as use any slide number references if it's particular to a slide. So we'll start with the Q&A box, and it's on slide 32, from Magdalena Padilla, is interpreted as an indicator of sales to dealers, but that does not mean sales to consumers. To better reflect that consumers have actually purchased the EVs, any discussion on conforming ACC2 to reflect sales to consumers. And Anna Wong has dealt with this question for a long time, so I'll let her answer this one.
Yeah, thanks for this question. We aren't considering changes to how we impose requirements on manufacturers, since that's how all of our fleet average standards, of which the greenhouse gas requirement is a fleet average standard, applies to vehicles delivered for sale here in California. That's how all light duty standards are applied in criteria pollutant space, in greenhouse gas space, in the ZEV space, and EPA does the same thing. So that's not necessarily on the table at this moment or for this rulemaking.
And I'll add, since we are proposing to remove the ZEVs from the fleet average, then perhaps this is also less of a concern. The next question is from John Yarrow. Have you thought about what you might expect from small volume manufacturers from today up to 2035 model year, who are likely to have a smaller PHEV and ZEV fleet content than the larger manufacturers in any given model year, recognizing that EPA rules will be requiring small volume manufacturers to meet more stringent fleet averages than CARB's flatline? Anna Scadell, do you want to take this one?
Sure, and I see we have two questions on sort of the treatment of small volume manufacturers, and I think the response covers both, which is that, as you see, we didn't have a proposal today for the treatment of small volume manufacturers, and this is something we're still thinking through and really open to input on. I think we recognize that there's likely a need for additional flexibilities, and we'd be interested in thinking through what would be useful, but also recognizing that, especially with an ICE fleet average standard, we want to look at what those small volume manufacturers will likely be doing with their vehicles to meet the EPA rule as well. So I think this is something we're very open to hearing more about, and we'll think through as we think through the overall stringency.
Okay, next question from Ashley Ramanathan. How would banked greenhouse gas crediting from ZEVs accrued prior to 2030 be used in the ICE-only fleet standard?
Yes, I can take that question. So the way that we're thinking about this treatment of the Advanced Clean Cars 1 credit banks going into Advanced Clean Cars 2 here in the 2030 model year, those credits that were accrued in the ACC1 program, we're not going to sort them by, was it from a ZEV? Was it from an ICE that was cleaner than the standard? It's just the overall performance relative to that projected, what the projected target would be as sort of a federal equivalent standard. So there won't be a distinction depending on the technology type that was used to generate the credit. I hope that answers the question, and if not, please raise your hand and we can try to clarify.
Okay, next question is from Michael Hartrick, medium duty passenger vehicle proposal. Is this only for ACC2 greenhouse gas, but are you also considering changing approach for criteria emissions? I think the answer is yeah, the definition would apply sort of globally to all of our emission programs. So it would also affect the criteria standards. And then the next question is from Beatrice Frick. Will CARB's greenhouse gas program be open for adoption in Section 177 states? And yeah, as with all CARB regulations, Section 177 state is eligible to adopt our program, provided they meet all the requirements of the Clean Air Act that enables them to do that. So we don't actually have any authority as to who gets to adopt our program. So I think maybe we can switch to some of the hand raisers now, Cody, and we'll come back
Sure.
to the Q&A box after that.
Sure. Neil Kohler, we have unmuted your line and you are free to speak. Please remember to state your name and affiliation.
Thank you, and thank you for the presentation, Neil Kohler with the Renewable Fuels Association. A question that harkens back to the November workshop when there was a request for input and a slide, I believe it was slide 32 then, on ethanol and specifically higher blends, E85. We've seen incredible success of E85 in California in consumption, yet we're lacking new flex fuel vehicles. And on slide 36, talking about, in this presentation, talking about the technologies, flex fuel technology, clearly as a way to significantly reduce GHG emissions, criteria emissions, and at a significantly lower cost to consumers. So maybe this is coming up in a future workshop, but I was just curious where the consideration of higher blends of renewable fuels is in addressing both legacy and future PHEV technologies and what we might see in terms of opportunities around that.
Yeah, so we don't have a proposal right now, and that's why there's nothing in this slide deck, but we are still evaluating this question and still welcome input from people. We are on the verge, hopefully, of starting a test plan with some flex fuel vehicles to see kind of how they perform to what we would anticipate would be the LEV 4 criteria standards under the cold weather federal test procedures, and also to various evaporative requirements. And this would help us kind of understand what the compliance costs would be for meeting our criteria standards if we were to also have some either incentive or requirement for flex fuel vehicles. So I think we're still looking at this issue, much like plug-in hybrids. The benefit would come from the driver. So we are also trying to get more data on, how likely do drivers actually fuel with E85 based on, the different prices of the different fuels and kind of what the availability is of that fuel. So if you have more information to share with us, we're open to hearing it.
Excellent. We'll continue to engage actively on the topic. Appreciate that.
Cody?
Christina Kubran, we have unmuted your line and you are free to speak. Please remember to state your name and affiliation. She might be.
Hi, thank you so much. My name is Christina Kubran. I just started 352 Innovation, and I wanted to ask about the hydrogen combustion engines, because they would be a great way to reduce emissions out of internal combustion engines. And when they run in a hybrid type setup where they're fixed in a fixed operating space, they can be zero emission. I just was reading a few papers about that, and it would drive hydrogen sales. And they had one out, a demo truck from Cummins and Southwest Research Institute at the California Hydrogen Leadership Summit a few weeks ago. So I wanted to ask about that.
Is your question like specifically how they would be treated under the proposal, or just like how much do we think about hydrogen internal combustion engine vehicles?
Well, I guess what I'm asking is more like, have you guys considered putting out regulations for it and allowing it to become active, because it would drive hydrogen sales tremendously, and it gives small businesses a much cheaper option to convert their fleets, which is a small mod, to run their same fleets on hydrogen, and then they don't have to dump all their inventory and buy all new stuff, all at once to meet all these regulations, and it rapidly reduces emissions over diesel or gasoline for sure. And it's gaining a lot of momentum, and Cummins has got ones out for sale. They want to sell them for big rigs and stuff, and they're switching ships over to run on ammonia and methane and hydrogen, or combinations of the two for shipping. And their Rolls-Royce is putting together an engine. Ferrari's building one. Toyota's already raced in 2 24-hour races with liquid and gaseous hydrogen. Mazda's already built a hybrid hydrogen ICE and dual fuel hydrogen ICE. And so it's here. And I just wanted to chime in and give a little push, I guess, to say, please let it happen.
Well, I think historically under the ZEV regulation, hydrogen internal combustion engines don't qualify for ZEV values because they do have some small NOx emission level. So they wouldn't, I think we would maintain that position, but given kind of how we're viewing the new kind of ICE only paradigm under the greenhouse gas program, those vehicles could then be kind of counted in your greenhouse gas average. So we don't preclude them per se in like the fleet averages of non-ZEVs. They're allowed, but so far nobody has actually produced them commercially.
Well, they were selling them in Japan to drive the infrastructure over there. Mazda, because the beauty of it is it's best when it's direct injected, so you can still run port injected or carbureted gasoline, and you can run on either fuel if you don't have hydrogen. And the best part is that once the infrastructure, like I'm a member of Arches too, so I'm very vocal about saving that sweet symphony of controlled combustion, and they can run on a dirtier mix of hydrogen. So as the quality stabilizes, as the production gets going and the quality stabilizes, fuel cells won't be able to use some of it if there's a problem with the quality, but you can run it on down to 60-70% hydrogen, still sell it to an IC engine. So just something to think about. It can become zero emission if it's commercialized and they get the funding behind it. They were getting near zero emission and literally zero emission under certain operating conditions 20 years ago in these papers I've been reading. And injectors didn't even exist for those things at that time, nor the control systems. They had to piecemeal everything together. And now you got BorgWarner making ECUs for it because they're supporting Toyota, and their piston ring manufacturers making piston rings for H2 ICE. And they're coming out with injectors specifically for hydrogen. And so eventually, I don't see any reason why the lubrication couldn't move away from a fossil fuel base in the future anyway, because you no longer need that lubrication to hold any hydrocarbons because it burns so clean. You just have to make sure it's compatible with a little bit of water. And so I think it could eventually reach zero emission status if it has enough, I guess, money behind it is the root of the problem, but it certainly can, especially in a hybrid situation where it's in fixed operating cycles. Then it can be literally zero emission. You wouldn't have the transient NOx or anything when you throttle up or down. You would have it like I used to work on locomotives, and locomotives work in a fixed engine operating scenario at a certain RPM and a certain load for each of the notches, and all it does is create electricity for the traction motors. And that's how you could run it in a hybrid and fix it in these operating conditions where it'll make zero NOx, So there's a lot of potential there. It would really drive hydrogen sales. It would save a lot of jobs and keep mechanics going and keep classic cars classic. It would give us something to run on once fossil fuels are no longer available. So thank you so much for hearing me out. I appreciate it.
Okay, thank you for your comment. Next, we'll go to Thomas Van Heek.
Tom Van Heek, we have unmuted your line and you are free to speak. Please remember to state your name and affiliation.
Hey there, this is Tom Van Heek with Rivian Automotive. Thanks for the great presentation. In particular, just personally, I thought the BHEV data was really interesting, so thanks for sharing that. One point of clarification, one question. I just want to confirm that I'm interpreting correctly that right now it appears CARB is proposing that the greenhouse gas standard prior to MY30 would remain at the flat line. Is that correct? Okay, I see 9.
That's correct. Yes.
Okay. That's a helpful clarification. Thank you. And then we heard a question earlier related to pre-MY30 earning and carry forward of GHG credits relative to powertrain. That was the answer to that was helpful. On a related note, post MY30, you mentioned considering a possible flexibility for OEMs to trade excess ZEV values into GHG space. Would that be limited to a single OEM's fleet, as in they would need to trade their own excess ZEV, or are you entertaining potentially envisioning a world in which excess ZEV could be traded across OEMs into GHG space?
Yeah, thanks for that question. I can address that. And I see we also have a question in the Q&A about sort of the treatment of the ACC1 greenhouse gas credits. So I'll talk about both of those at the same time. So Tom, to answer your question, the vision for the excess ZEVs moving over into the ICE-only fleet average, the vision there is that it would be applied in a really limited way, and it would be just one manufacturer's own excess ZEVs. So a zero emission only manufacturer that isn't subject to the greenhouse gas standard would not be able to bring over ZEV values from the ZEV reg into the GHG reg. The idea here is really just to provide a limited pathway for the manufacturers that continue to make internal combustion engine vehicles, but are ahead of the game on ZEVs to give them a compliance pathway. But the idea is not for just moving ZEV values around from one regulation to the other. So the idea would be it's one manufacturer's own excess ZEVs, and they can count it in one or the other. There would be no double counting. So I hope that answers that. And then just while I'm talking about credits, there was a question in the Q&A about from Michael Hartrick about what's happening with the ACC1 greenhouse gas credits in 2029. I want to clarify that we're not proposing to have all of the ACC1 greenhouse gas credits expire going into 2030, just the ones that are basically generated by what a manufacturer would have had to do under EPA's standards anyway, which is very much what we expect they would need to do. And again, because they're going to be complying with the ZEV regulation, we expect that over compliance with our standard. So it's just some of the ACC1 greenhouse gas credits would expire, but anything over what we sort of estimate compliance with the federal equivalent standards would be, they would be able to carry forward. So I hope that that answers those questions. And Tom, if you had another follow-up, I didn't mean to derail you with the answer to another question, but.
No, I'm glad you answered that question as well. That's it from me for now. Thank you for your very helpful response.
Dean Taylor, we have unmuted your line and you are free to speak. Please remember to state your name and affiliation.
Hi, can you hear me?
Yes.
I'm Dean Taylor, representing the Strong Plug-in Hybrid Coalition. I have a few questions on plug-in hybrids. Can you show slide 32 and maybe explain a little bit more how you get your assumptions on plug-in hybrids at 5% up to 2034 and then going to 10% in 2035?
Sure. So these are the sales projections that were part of the Advanced Clean Cars 2 rulemaking. So this is just exactly consistent with what was projected for that.
So do those numbers then translate over into slide 34?
Yep, the numbers are identical. We just took away the...
I'm sorry, go ahead. A follow-up question then on slide 34, is there a fleet utility average, percentage of gasoline versus electric miles also assumed in slide 34?
Yeah, I think that we used EPA's Omega outputs to generate the projected California fleet average emissions. So those have embedded in them EPA's assumptions for the plug-in hybrid utility factor.
When you say EPA's assumptions, they, as you know, that they're using SAJ 2841, I think it is, for up to I think model year 2030, and then shifting to the new proposal. Is that what you mean?
Yes. So it's basically everything that is in EPA's FRM.
Got it. And then on slides 37 and 38, you're not counting any of the electric miles. So am I understanding? So if you had a plug-in hybrid 20 or a plug-in hybrid 50 or a plug-in hybrid 150, they're all, or even a regular hybrid that doesn't plug in, they're all treated the same. Is that correct?
Yes, that's correct.
So no factoring in of other, other considerations like pack size and upstream battery mining or manufacturing emissions, anything like that.
Yeah, what we're looking at here for the ICE-only fleet average standard is just those tailpipe emissions. And so whatever the plug-in hybrids charge sustaining emissions are, regardless of the all-electric range, is what we would be using as the compliance value for the ICE-only fleet average standard.
And then if I'm hearing you right on slides 45 to 48, regarding all of this, there's no real proposal at this time. I mean, it may be this rulemaking or maybe a future rulemaking is when you may do something, but there's no proposal really based on all of the data you're collecting.
Yeah, that's right. It's more of an update on some of the analysis that we're doing. And a big piece of that, though, is for us to understand the emission benefits of our programs. And so while we're not proposing any design requirements on plug-in hybrids, and we're not looking at changing the plug-in hybrid provisions in the ZEV regulation. We certainly expect manufacturers to continue to use plug-in hybrids as a compliance mechanism in both programs. And so we want to make sure that we are continuing to understand what the emissions are from those vehicles, and so that we're accurately understanding the benefits of our programs. And so to directly answer your question, there's no proposal here, but it's something that we're continuing to look into.
But slide 33 really is in some ways the proposal, because that kind of deals with the whole issue of plug-in hybrids. Is that correct?
Yes, so with that, I think 33 is the one where we have the side-by-side. So yes, the proposal here is that we're not looking to estimate the EVMT share for compliance with the ICE-only fleet average standard, but we do quantify the benefits of our regulations. We do, we are continuing to investigate this more broadly as part of our programs, but the proposal for compliance purposes for the ICE-only fleet average standard would be just the charge sustaining emissions from plug-in hybrids, regardless of any of its other features.
And I want to make sure I also get something right, is that EPA was basically having 0 grams per mile for upstream. CARB was including upstream emissions from, I guess, power plants. But now you're proposing essentially to harmonize with EPA at 0 grams per mile. Did I get that right? For upstream.
So, well, the way that it worked in our program is we assess the incremental upstream emissions from zero emission vehicles and from the plug-in hybrid EVMT share compared to gasoline. And because those vehicles aren't going to be in the subject to the fleet average, we have no need to assess the incremental upstream emissions.
What do you mean by incremental upstream?
Belinda, do you want to clarify?
Well, it's more like the difference between gasoline and the electricity upstream. So it's not that, because we don't want to just say, we're only going to look at the ZEV upstream emissions, we have to kind of also then factor in the gasoline upstream emissions. So rather than do it, adding the upstream emissions for gasoline, we just kind of look at the difference between the two.
And last question, going back to slide 32, when you had the 10% in 2035, is that kind of hidden behind that? Is that assuming that an individual manufacturer can do 20%, but overall some of and there's banking and trading, so it's assuming that a lot of manufacturers are 100% ZEV, so they won't be doing any plug-in hybrids. So when you factor that in overall, they're only 10%. Is that how you arrived at that number?
Yeah, and again, these numbers were sort of the likely, what we projected in our Advanced Clean Cars 2 rulemaking. So I don't think we expected that every manufacturer would max out at 20% plug-in hybrid. So and we're happy to send you the rulemaking documents from Advanced Clean Cars 2 that walk through this in more detail. But this is based on what we estimated the fleet mix would look like in 2035. But yeah, it's as you can see, it's clearly not 20% plug-in hybrids.
Thank you.
Delaney Williams, we have unmuted your line and you are free to speak. Please state your name and affiliation.
Hi, thank you for the presentation and for taking my questions. I'm Delaney Williams. I'm from Pennsylvania Department of Environmental Protection. I had 2 questions. First, in the analysis of plug-in hybrids real-world benefit, did you incorporate just the default setting of cars? I've driven a plug-in hybrid that just always starts in gas-powered mode, in your considerations of what the default setting is when you start a car? Is that clear, the question?
You're asking about the data that we have and how we evaluated it?
Yeah, if that was one of the situations that you analyzed when looking at the real world plug-in hybrid emissions.
Yeah, so the data that we get is sort of kind of cumulative over the life of the vehicle. So I guess I don't know specifically which models may have that default setting that your gas engine only turns on. And I don't know exactly, you know, if that's a setting that the driver chooses or that's sort of like the factory setting. So we didn't look at the data at that level of detail to be able to parse it out.
Okay, thank you. And then my second question might be more of an opinion. So in Pennsylvania, we are a Section 177 state, but we did not adopt CARB's ZEV percentage requirements. So would adopting the greenhouse gas standards that exclude ZEVs de-incentivize adopting, like ZEV adoption in the state?
This is like a brain teaser.
It is a bit of a brain teaser. And it doesn't need to be answered now in real time, but it's something that I'm definitely considering because I don't I'm worried about a loophole being introduced when we adopt, because we automatically adopt CARB's regulations when they come in. And so if there's no reason to have ZEVs because there's not the fleet average requirements in EPA's rules, I'm worried it could cause more problems than create benefits. But it would probably be a person. I just don't know if y'all had any impression of what that would do without the ZEV mandate and ZEV percentages.
Yeah, we'll have to think about this more and maybe get back to you offline.
Okay, thank you so much.
Yeah. Gil Tall, we have unmuted your line and you are free to speak. Please state your name and affiliation.
Hey, Gil Tal, University of California, Davis. First, thank you for great presentation and really good work. I think that some of my questions, sorry for not typing it in because I'm still forming it. But my general question is about plug-in hybrid tools and motivation to make them better. What's left for longer range or more efficient EV driving? Is there something left in the ZEV mandate or the fleet GHG? That's my first question.
You mean to make them more
To any
longer
credit
range?
for any credit for an OEM to go over the minimum range or getting a more efficient or a better charging and so on. Because we are worried about the utility factor. So does the new proposal of dropping it leave anything for that?
No. I think this is something we continue to explore, is whether or not, if we don't have the EVMT side of it, what would motivate a person to charge the vehicle to actually get the emission benefits from the vehicle. So I think right now we're not looking to change the ZEV requirements for plug-in hybrids. So it's just something we're going to have to keep watching. And of course, we don't regulate efficiency, so we don't have anything there.
Yeah. But anything about the electric drivetrain? My concern is post 2035, this vehicle will be matched with no charging households, and therefore we will just have hybrids with heavy battery drives around. And I think we may create a loophole with the current proposal.
Okay, well, we'll have to think about it more, and happy to talk with you more.
Yeah, thank you.
Okay, so let's switch back to the Q&A box. Continuing on our plug-in hybrid thread, here's a question from Dave Reichmuth. For the hybrid or the higher PHEV real-world emissions, are there any trends with vehicle types or size or with manufacturer? And yeah, we haven't looked at it in that much detail, so I can't say that we can answer this question. And then the next question is from Matt Pope. Currently, OEMs have up to 5 model years to settle compliance, which allows for OEMs to transition their fleets and carry back over compliance. Do you foresee this occurring with this rulemaking? And I would say right now, yeah, we're not planning on changing credit life or the kind of carry back time period either. I know EPA has a slightly different one. We are not at this time thinking about changing anything we have now on that front. Next question is really more of a, I think, comment from Thomas Green. 2 reasons the real world emissions might be higher is that the certification tests do not reflect real world driving, and the PHEVs are generally more powerful than traditional ICE vehicles. So while those buyers typically want to save gas, they are more tempted to gun it for a sporty feeling. So yeah, like Anna mentioned, we are still looking into the differences between certification and real world emission levels. Another question from Magdalena Padilla. Are you moving in the direction of providing automakers more flexibility in meeting tailpipe emission reductions through the sale of great number of plug-in hybrids, which consumers are more readily buying over EVs now, as the consumers are not the early adopters? So I don't know if that's a question more for the ZEV regulation, but I think in the greenhouse gas regulation, you know, there's no limits on the number of plug-in hybrids that a manufacturer can produce. So certainly if they want to meet their kind of consumer demand through producing plug-in hybrids, I think where we set the stringency of that ICE only fleet average is, you know, likely to be kind of within the capabilities of a plug-in hybrid. So I don't think we're precluding anything there. The next question is from Daniel Ingbar. It appears the treatment of the plug-in hybrid utility factor you have discussed here and the disconnect between EPA's projected pathway for compliance versus those allowed by the ACC2 ZEV requirement will create significant divergence with EPA's projected pathways for model year 27 to 32. Is CARB concerned that the different regulatory regimes between 177 states and non-CARB states will distort the allocation of vehicles among the states? Will CARB consider amendments to the ZEV program under ACC2, especially as it tracks compliance with model year 2026 ZEV requirements in California and CARB states? I think basically we set our own standards and we kind of let the other states decide if it makes sense for them and to meet their needs. So this is similar to the question I think we got from Kelly. We'll just have to think about this more. Or unless Anna has more to add to this.
The end of that question was asking if it's considering amendments to the ZEV program, and I believe Anna Scodell said it at the beginning that we're not necessarily opening up the ZEV regulation for considering a new stringency, if that's what that question is, if I can interpret that question as asking if we're considering to change the ZEV stringency. But I agree with what Belinda said as well.
Okay, moving to Luke Spinolo. Battery cooling on BEVs and plug-in hybrids, plus the addition of, sorry, Tao, can you mute just a second? Okay, battery cooling on BEVs and plug-in hybrids, plus the addition of heat pumps on BEVs means the number of refrigerant joints typically increases. Even with the best joint types, meeting a target of 4 grams per year will be difficult. This can effectively eliminate any incentive to maintain the best joint. Would CARB consider maintaining AC leakage credit consistency with EPA to provide the best incentive? And this is referencing slide number 42.
Yeah, this is Tao Zhan. I can take this question. Thanks for the question. So first of all, BEVs wouldn't be subject to the fleet average standards. So this question will be applicable to PHEVs, but not for BEVs. For PHEVs, just to clarify, what we're showing on the slide, the chart is an example calculation. We are still in the process of evaluating what kind of values we wanted to set for the sliding scale and the credit amount. And that's an ongoing process. So we will be taking the best available data, including our own certification data and any other external data. For example, the Minnesota AC leakage reporting data. We'll be taking all those data in our evaluation when setting the actual values for the calculation. But that being said, we do recognize there's a value to set the target a little bit more stringent than what EPA is setting. So I think there are probably slightly different policy focuses. You could set the value relatively high as a way to prevent backsliding to the higher leakage, or you could set the target lower in a way to promote the best technologies to really drive innovations as far as the AC leakage is concerned. Hope that answers your question. Thank you.
Okay, next question is from Jackie Yeager. Any changes under consideration for medium duty greenhouse gas standards? And so those are at CARB, those are handled by another group. So they're, I think, contemplating that as well as the phase 3 updates. So they will not be part of this rulemaking. And then maybe more of a comment from John Yarrow. Plug-in hybrid owners do not make full use of the fully charged battery, i.e. they don't maintain a fully charged battery, but rely on the mild hybrid capability. Oh, so the fully charged battery electric range isn't utilized. And then the last question is from Sashi Venati. A request, can the data behind slides 46, 47, and 48, the plug-in hybrid, I'm assuming real world emission data, be made available for OEMs for review and further analysis? So we do get this data from the Bureau of Automotive Repairs, so we would have to check with them before we release it, but that's a request that we can make. Okay, any other last minute hand raisers here or open Q&A box? Otherwise, we're going to move on to the ZEV portion.
Thanks, Belinda. We'll now turn to the last topic for the day, our zero emission vehicle assurance measures. Joyce Wong on my staff, who's going to turn on her camera because everybody gets to see her, is going to cover our ZEV assurance measure, which is focused on a consumer-facing label. And then Ryan Hart, who's also, there he is, will cover interoperability and then touch on a few updates on implementation of the battery label and data standardization requirements that were adopted under Advanced Clean Cars 2. Okay, then we'll have today's final round of question and answers. And so now I get to turn it over to Joyce.
Thank you. Another topic we are focusing on in this rulemaking are updates to the California Environmental Performance Label. As mentioned during the November workshop, California has its own vehicle sticker called the California Environmental Performance Label, dating back to 2008. It includes both smog and climate information. This was a supplemental label that manufacturers were required to provide, along with the fuel economy label seen on the right. It was incorporated into the fuel economy label in 2011, which we have allowed manufacturers to use to comply with California's label requirements. We want to make sure that consumers have the information they're looking for when they are considering a ZEV purchase. To that end, we are developing an updated California label with improved ZEV metrics, which would accompany the federal label on new car purchases in California. We distributed a survey in early May to understand which topic areas are most important to consumers. The survey was sent out through multiple avenues, which include CARB's listservs, CARB's social media, air district, nonprofits, community-based organizations, and non-governmental organizations, such as our partners at the Northeast states for coordinated air use management. Based on the comment letters we received in November, we focused the survey on these topic areas: range, charging, battery, environmental scores, and current label information. There were over 2,400 respondents. The results of the survey show that most respondents use the federal label to inform their car purchases. They also indicated that many other sources that draw their information from the label data, such as manufacturer websites, EV-specific websites or forums, and news articles, are used as well. The top themes we saw from the survey were including more real-world range numbers, such as an estimated highway range. Respondents also wanted to see the lowest possible range, which results from driving ZEVs in extreme cold or hot temperatures. The results also showed that DC fast charging times should be added to the label to help inform longer trips. Currently, only level 2 charging is on the federal label. Lastly, information on the battery warranty and the efficiency of the vehicle should be provided. We also saw that some respondents did not want metrics such as miles per gallon equivalent and smog and greenhouse gas scores to be included on the sticker itself. Some respondents voiced that these metrics are not necessary for ZEVs. Many respondents expressed concern over the amount of information on the current federal label. With that in mind, staff are proposing to provide more detailed information behind a QR code. This will allow us to focus the label on displaying the key topic areas important to ZEVs, such as range and charging, while the QR code will be an avenue for those who want to know more. With these results, we will take the input gathered from the survey and start designing a mock California label. Once it is designed, we will be workshopping it around for feedback. In tandem with our proposal to add new range and charging metrics to the California label, we are looking into test methods to obtain and present more meaningful range and charge speed data. For range, we are supportive of changes to SAE J1634 that would allow for high speed to be calculated from data that is currently collected from testing. High speed range better reflects real world conditions, as people often drive at speeds greater than 60 miles per hour in the highway fuel economy tests. Also, range at high speed is generally more worst case, which is something we know consumers want to see. For charging, we are proposing to use SAE J2953/4 to collect charging speeds. The current 0 to 100% state of charge at level 2 is not reflective of real world usage. Currently, we are proposing to require manufacturers to use the J2953/4 procedures to collect and report both AC and DC fast charging data in consistent and standardized manner. This could then be used to create a meaningful metric, such as miles recovered from 10 minutes of DC fast charging and miles recovered from 1 hour of AC charging. The committee is taking a realistic approach to ensure consistent starting conditions for the charging event and to collect data that could be used in a couple of different ways to present results to consumers for comparison shopping. While we are still getting up to speed with the committee and starting to ensure it will meet our needs, it certainly appears to be on the right track. If any OEMs have data, information, or alternatives regarding charge rate or range test methods, we will consider it. I will now pass it on to Ryan Hart to cover interoperability and the battery label.
All right, thank you, Joyce. reliable public EV charging is critical to successful mass EV adoption. The charging ecosystem is complex and has many actors and many points of failure. As we first brought up in November last year, staff is exploring amendments related to charging interoperability. While the term interoperability could apply to many things, we are referring to communication between the vehicle and the charger. Manufacturers implement specific communication protocols developed by different standards organizations on their vehicles to ensure their vehicles can communicate with the charging equipment. Examples of common communication protocols deployed today include DIN 70121 and ISO 15118-2. Charger manufacturers likewise implement communication protocols on the charging equipment. Following these communication protocols, where the vehicle and charger know to speak the same language, is important to ensuring that the charging cable is properly connected, that payment information is secure and can be authenticated, and that the vehicle and charger have agreed upon the parameters for charging, like voltage and amperage, such that charging can begin and continue safely. When communication fails, power flow between charger and vehicle may never start or can be cut off, and the vehicle will be unable to charge. Having a robust and reliable charging experience will go a long way for drivers on the cusp of zero-emission vehicle adoption. CARB sees a pathway from the vehicle side to reduce the number of failed charging events. Vehicle manufacturers, charger manufacturers, and charging service providers are all well aware of charging session failures. In the absence of required standardization, large in-person testing events have helped bridge the gap to help each of these parties better understand root causes of charging failures. At one of those testing events, 2023 volts, approximately 20% of the total attempted charging sessions failed. With nearly 80% of those failures being attributed to communication issues, I will also note that no failures occurred during this testing event once a charge session had successfully been started. In one-on-one meetings with CARB, manufacturers have confirmed these findings with real-world data that show that the vast majority of failures occur while a charging session is being established prior to power flowing. This points to a need for standardization and consistent implementation of these communication protocols. According to one of the few detailed studies published, payment and payment authentication represents a significant portion of failures when establishing a charging session. Failure during the payment authorization can be due to many different factors, including system timeouts, human error, and issues with payment authentication. If payment authorization is not completed, it typically results in the consumer being unable to charge. Included in the ISO 15118-2 communication protocol is an optional feature called plug and charge. In vehicles with plug and charge capability, the payment process is simplified for the driver by storing a payment card and driver profile with the vehicle. The vehicle then communicates with the network for charging needs and payment for the charging session. This allows the driver to plug in their vehicle and walk away with little to no interaction with the payment hardware on the charger. Vehicle manufacturers have told us that the plug and charge feature has been implemented on approximately 15% of the plug-in models available today, with more coming in the future. Some manufacturers that have plug and charge today have indicated that payment authorization failures have dropped to an almost non-existent issue when plug and charge is used on compatible networks. Public infrastructure funding, like the Federal National Electric Vehicle Infrastructure Program and legislation like California's Senate Bill 123, will require charging networks to be plug and charge capable on new installations starting this year. Given the potential to greatly reduce failures preventing charging from even starting, CARB sees an opportunity to align the vehicle requirements with infrastructure requirements by also requiring vehicle plug and charge capability. So where does that leave us for our proposal? Every battery electric vehicle on the market today implements DIN 70121, and more than a quarter currently implement ISO 15118-2. Based on information confidentially submitted to CARB, most manufacturers plan to implement -2 on most battery electric vehicles over the next 3 model years. CARB is proposing to require both DIN 70121 and ISO 15118-2 communication protocols for for battery electric vehicles and fast charge capable plug-in hybrid vehicles. CARB is also proposing to require plug-in charge capability as part of manufacturer's ISO 15118-2 implementation. As we highlighted 2 slides ago, communication issues between chargers and vehicles continue to arise even in the presence of standard implementation. This could be due in part to how manufacturers actually interpret and implement standards, which means requiring the standards alone may not address the issue. Conformance testing, like that which is required in onboard diagnostic compliance, can help to ensure consistent and reliable implementation of these standards across vehicles and manufacturers. This, in turn, would be a tremendous benefit to charger manufacturers who could attune their own implementation of communication standards, knowing vehicles would reliably communicate in the same way. Staff is working with the SAE J2953/3 committee to develop an effective conformance test for the DIN and ISO standards. We welcome others in this space, including charger manufacturers and network providers, to join this committee. Before we wrap up, I also want to provide updates on proposed changes to 2 existing ACC2 ZEV assurance measures, battery label requirements and the data standardization requirements. In 2022, as part of the ACC2 rulemaking, CARB adopted requirements for manufacturers to include specific information on vehicle batteries to support servicing the battery and recycling or reuse. CARB has been working with manufacturers on implementation of this provision as manufacturers have begun to develop battery labels and associated websites to meet the requirements. Most of those issues center around production logistics and how the data repositories should be structured. We are proposing certain changes to address implementation issues. The key change is to remove the requirement that the 3 different vehicle, pack, and module labels be identical and instead identify the specific information that should be included on each label. We will propose several non-substantive changes and expect to release draft regulatory text in the fall for input. Similarly, we have been working with manufacturers to implement the ACC2 data standardization requirements as 2026 model year vehicles move through the certification process. Through this communication with certification staff and manufacturers, staff is proposing a few clarifying changes related to which maximum charge rate to display when AC charging and which to display when DC charging, as well as newer UDS protocols on older devices and other items. Along with non-substantive changes, we are proposing to have the battery state of health display be rounded to the nearest whole number rather than the several decimal places currently required. We are also updating references to SAE J1979-3 and the J1979-DA to the latest versions available. As with the battery label regulation changes, staff plan to release draft regulatory text for consideration in the fall. And with that, I'll hand it over to Anna Wong for our question and answers.
Thank you, Ryan and Joyce. Yes, I do. Okay. I also completely blanked and did not get to introduce other staff that are supporting these efforts. So I just want to give them a chance to come on camera. One is Stephanie Palmer. If you were around to wave and say hi, she'll be helping on the interoperability work. Banpreet Baramba as well. I don't know if she can because she's sharing her screen, so we'll just assume that you all know what she looks like. And as well as Jeff Ongnok is also on. He's helping with our label regulations and our battery labeling. And then also Natalie Reevy and Lisa Kilodikis are also here. You got to see them earlier, but they're also helping on parts of the rulemaking, Lisa on the labeling regulations, and Natalie on some charging issues. Lastly, Adrian Harris, if you are around. Adrian is also working on some charging issues that have arisen as well. Okay, with that, just as a reminder, to be added to the speaking queue, please raise your hand. For those joining through Zoom, click participants, then raise hand. For those on the phone, press *9 to raise your hand. You can also use the Zoom Q&A box to submit your questions. When you are speaking, please share your name and affiliation before asking your question. And if you have a question on a particular slide, please reference the slide number. So I'll start with the ones that we've received through the question and answer box. This is from Thomas Green. This was during the during the presentation, so just to put it in context, it says, correct. The plug-in hybrid and battery electric vehicles typically try to keep battery charge over 20% filled, so that affects the real-world data, whereas the test typically aimed at what is the maximum efficiency. Perhaps the vehicle label advertise both the maximum efficiency test results and real-world expected mileage. And Joyce can confirm, but we received similar comments during our survey, and I would agree that we're considering these types of issues as we think about the battery label, the environmental performance label proposal. The next question comes from Vitrio Riccardi. I'm so sorry if I said that incorrectly. Do you still foresee the possibility to comply with the California label requirements with the federal one? We are continuing our long-standing relationship with EPA and looking forward to working with them as we develop the label. It is not considering an open, it's not currently an open rulemaking in the EPA space, but we expect to want to work together with them as we consider these things, as we know that in past years that our changes have been incorporated into federal labels. This is another question from Thomas Green. Could the ratings put on the label also list at what payload weight level? We need to know if the listed range is for one very small driver or a full payload of people. Again, this would more than likely anything that is numbers that are tested under the EPA regulations and how those tests are run, that all really falls within the EPA space. But it's something to consider as to how much information people want to know about the values. We would plan to release this data publicly as EPA does for their label. So that data could be included in that release of the public data. Do we have any hand raisers? Do you want to go to that now? That's 3 questions, but I can keep going. Okay,
Sure.
Go ahead, Cody.
Okay. David Reichmuth, we have unmuted your line and you are free to speak. Please remember to state your name and affiliation.
Hi, David Reichmuth. I'm with the Union of Concerned Scientists. I just had a question on the labeling. It's, I think for the DC fast charge, I believe the slide said miles in 10 minutes. Is that correct? Yeah. I would maybe consider, I hope you could consider a different charging metric that takes into account the fact that some vehicles have a very high peak rate that is over a very small range of state of charge. And that might, for some vehicles, that would maybe be a high number, but not reflect the time required to go 20 to 80% charge, or the time to get 100 miles, or some other metric that would take into account vehicles that have a charging curve that is far from flat.
Yeah, that's a good comment, Dave. What is being proposed here is what is in that SAE standard. So that committee is still ongoing and considering these sorts of things. So I hear you, and I do think that it's important what those say. What we want is reliably consistent metrics across all manufacturers, and that SAE procedure allows us to do that in a more consistent way. So that's why we're proposing those charge rates. Okay.
Okay. Romik Ayavaz, we have unmuted your line and you are free to speak. Please remember to state your name and affiliation.
Thank you. My name is Ramik Avaz, speaking on behalf of EVgo. Appreciate the opportunity to speak today. I have a question about adapter standards. As we continue in the transition to the North American charging standard. We know adapter safety and performance are going to be increasingly critical for the consumer experience. EVgo has consistently supported the UL 2252 certification requirements for adapters to ensure safety and reliability. So I wanted to ask staff to share any insights or thoughts on CARB's plans to update or strengthen adapter regulations as part of CARB's revisiting the Advanced Clean Cars 2 regulation.
Thanks for that comment. There's a lot of things in your question, so I'm trying to make sure to answer really what you're trying to say. For the adapter UL standard, I believe right now, if I can remember the regulation correctly, and any of my staff can come on and correct me even more, I believe that a UL standard is not named, but it is that it has to apply to applicable UL standards. So it's just to say that it's a good comment, and we'll take it under consideration as we're thinking about any updates to further clarify what could be met with those adapters. So thanks for that comment. I think that we would definitely be considering it during the rulemaking. Okay, we are going to keep going down our question and answer list. Where am I at? Okay. Will the battery label and data standardization be delayed for lead time concerns and implementation? This question comes from Beatrice Frick. For most of the battery label and data standardization concerns would not affect the actual design of the vehicle. These are really clarifying changes, we would say, non-substantive changes. But we would welcome if these types of changes, which we have heard from industry would be very supportive of, if they would cause lead time concerns, we would happily take comment on that. This question is from Lisa Mirasola. If the label includes range and recharging time for battery electric, please provide range and refueling time for hydrogen fuel cell. Both may need to be included for a plug-in fuel cell like the Honda CR-V EFCEV, which I'm assuming stands for electric fuel cell electric vehicle, but I'm not sure. Yeah, at this time, we are really thinking right now about battery electric vehicles, but it's a good comment to continue to think about how we can strengthen the label for hydrogen fuel cell vehicles, and would include plug-in hybrid fuel cell electric vehicles. So thank you for that comment, Lisa. Okay, this is from Connie Cho. For the SAE J1979 reference updates Ryan Hart mentioned for the 1962.5 or data standardization regulation, will the incorporated references be updated to a single more recent version, or will the reference mention allowing updated versions as well? Typically, we name the versions. We don't just we can't, I'm looking at a lawyer right now. Normally, we can't just say blanketly that we will go to the latest version. We have to name the versions, hence why we are updating the name of the version with a latest version. So that's the approach that we'll be taking. But if there is a version or some sort of update that you're expecting that you'd like us to pay attention to and that we make sure to include, please submit those specific recommendations to us. Okay. Another comment or question from Thomas Green. Could you consider using QR codes on the labels, also including the website below it? I know quite a few people without QR readers on the phone, and the QR apps and other apps can't be uploaded due to memory issues. This happened to me after loading Facebook, which is a memory hog. I think that's a really good comment, and I believe even on the EPA label it does have a tiny QR code, and I believe also the website's listed. So that's a good reminder as we develop what that QR code looks like on the label. Do we have any other hand raisers? I just want to make sure. Okay, I'll just keep talking and everybody keep looking at me. June Seop Choi has this question. Would you please provide more information regarding battery label position? What do you think of adding charge port cover as one of the allowed options? I would say we have not been specifically asked about that position. We are proposing, I think right now, the label is required to be in the frontal space of the vehicle where an engine normally would be in a vehicle. And we are updating that, I believe, to the door jamb, but it's interesting and it's an interesting suggestion and we'll take it under consideration. So thanks for that comment. This question comes from Matthew Hensley. When would the changes, clarifications to the BEV battery label requirements be effective? 2026 model year. BEV are likely to start production before the fall, and the car pairing will happen during that. I hear you, Matthew, and as we roll this out, I know that we have been in active conversations with manufacturers about what we can issue guidance through our certification group as those questions come in and what would actually require a regulation change. So I think that as we work through the process, we can talk about the timing and the lead time for those changes and what would be reasonable to expect for OEMs and how that approach might work. So we would welcome further conversations about that. Okay. Francesca Wall, given the question on NACS and adapters, do you still plan to incorporate the J3400 standard into the updated model year 2026 requirements? We are currently continuing to watch that standard development and welcome comments on what industry believes is the right way to move on the inlet standard for DC fast charging on vehicles. This is the last question I have, unless we have any hand raisers, and I'm looking at Cody and he says no. This is from Chris McCarthy. Would the ACC2 vehicle label require testing beyond the existing two-cycle or multi-cycle test, or MCT, or are derating values also being considered? For now, we are considering to look at what we can do with the range testing standards that are available right now to manufacturers and how we can use those standards to come up with some of these values. As you could see, Joyce in her slides presented a new procedure to gather a charging rate for both AC and DC charging. So we are proposing an additional test for that. It would not just be that two-cycle test. So we do expect maybe some additional testing to result from these labeling requirements. And those are all the questions that I have. We'll give folks another second or two to come up with any ZEV questions. Oh, and I think we have a clarification on one on the J1979 DA. Okay, Anna Wong, you're not quite off the hook yet. There's a few more. I'm so sorry. I'll have Ryan just. Well, I don't think this is just a clarification on Connie's question. So my earlier question was asked in the context of trying to avoid any backward compatibility issues that could occur if changes are made to the J1979 DA and early implementers use a version of the DA that is not consistent with the newer versions of the DA.
Yes. So I think we'd like to hear a little bit more about this on the specifics of any conflicts that would arise from adopting a newer version of the 1979 DA. So if you have any specific information about how that would affect the parameters that are required by the data standardization reg, that would be really helpful for us to hear more about.
Okay. And Connie just said, okay. Okay, I have another question. Oh, okay. Matt McGovern, how will you address EVs that are repowered with battery swapping rather than conventional charging? This has been brought to our attention over the last couple of rulemakings. We would welcome any conversations as to what that looks like. Right now, the rulemaking is not considering any necessarily battery swapping model or changes to accommodate a battery swapping model. But if you have thoughts or things that you'd like to see changed in the regulation, we would be welcome to those conversations. And now I don't think I have any more questions. Anna, if you want to get started.
Connie Cho, we have unmuted your line and you are free to speak. Please state your name and affiliation.
Hi, Connie Cho, Volkswagen Group of America. Sorry, I was going to type it, but didn't have the time. So in 1962.5 for the over-the-air data reporting requirements, it incorporates by reference a guidance document called Data Record Reporting Procedures for Over-the-Air Reprogrammed Vehicles and Engines using SAE J 1979-2, dated December 15th, 2021. When you refer to that document, it seems to have been a document created by the CARB OBD staff, as it does not include field names for the ZEV vehicle tracking data requirements under 1962.5. So my question is, will this guidance document be updated to include the ZEV tracking data requirement field names, or will there be a separate 1962.5 ZEV specific over-the-air reporting guidance document?
Connie, that's a really good question. I think that we'll have to, as our OBD staff are not currently on the line, I think that we'll have to get back to you on that, but that's a really good question, and thanks for bringing it up. Okay. And we have another question. Oh, I don't know. Okay, I'm hearing myself. Noel Baker, anything you can say on the non-substantive changes to the battery labeling that might come? Again, most of these changes would allow for specific information to the cell module and vehicle level of the data. So there was a lot of confusion around using the same label, and that it would actually be not helpful to label those in the same way. There was also some questions about location, whether or not it could be in the door jamb. So we are providing clarification through those changes. I think that there was, everything is escaping me as to other non-substantive changes, but those are two that are really standing out to me, unless Ryan, there's any others that you want to really point out right now. Okay, I do think that this will be a good opportunity to release some draft reg language and to consider to continue the conversation as we work through those non-substantive changes within the battery label reg.
Okay, and I think we will move on to our next steps and a discussion of our standardized regulatory impact assessment. But I do want to mention we have just a few more slides here to go over, and then we can hang on for an extra few minutes if folks have more questions that come up, either on what I'm about to share or on the rest of the presentation. So just, if you have more burning questions, please feel free to continue to add them to the Q&A or raise your hand. So now turning to requirements that are part of the standardized regulatory impact assessment process, which is something that's required for major regulations. The standardized regulatory impact assessment, or SRIA, is a point-in-time estimate of the costs and benefits that would result from the proposed amendments. And one of the requirements for the SRIA is to evaluate the costs and benefits of at least 2 regulatory alternatives in addition to the main proposal. For the SRIA for this rulemaking, particularly for the greenhouse gas program, we're planning to use a modified version of EPA's Omega model to estimate those costs. And we welcome public input on alternatives to the draft regulatory proposal discussed in this workshop. And in particular, we encourage input on other approaches that might yield the same or greater benefits than those associated with the proposal, or that may achieve the same goals at lower cost. So we invite you to submit those comments. Please ensure that those comments submitted on the SRIA alternatives discuss that alternative's ability to fulfill the purposes of the draft regulatory proposal as we've presented it today. And please submit the associated cost and benefit information and data sources to enable us to compare the economic impacts and a clear description of the basis for any cost calculations. And we do have an open public comment docket that's open through July 26th of next, and you're welcome to submit those alternatives to that docket. And so wrapping up with some next steps, thank you all for participating today. You've all been hanging on here for almost 3 hours. So we really appreciate your taking the time and your sharing your questions and initial feedback. As far as our next steps go, as I just mentioned, we have a written public comment period open now that closes on July 26th. So we invite you to submit your feedback there. We're also always available for one-on-one meetings, so please reach out to us at cleancars@arb.ca.gov if you want to chat. I also want to mention that we are partnering with community groups across the state to host a series of in-person community meetings later this summer and fall, which will also be helping to inform our proposal. And at the same time, as I mentioned, we're beginning our SRIA work. We've already begun some work to collect data and develop methodologies to evaluate the costs and benefits of proposals and alternatives. And we'll be looking at what we hear from you all as far as potential alternatives for the SRIA. And we plan to present updated proposals at a future workshop later this year. So please make sure to subscribe to our listserv for updates on all of these elements of our rulemaking effort. So that's it for our scheduled programming. As I said, we can kind of leave, we can hang on here for a few minutes if there's more Q&A, but otherwise that's the end of what we have if folks are ready to go ahead and have lunch if they're here in California.
So I see Steve Douglas put in a question about extending the deadline. We just issued the deadline. He's already asking for an extension for the SRIA costs and benefits data. So I think we are on a very accelerated timeline. So I would say the earlier you're able to submit these things, the better. Obviously, we continue to consider any new information that we get. So I think if something were to come in a little bit later, it's not like we would just, ignore it completely. So, but we would prefer that you could meet our deadline. Okay, well, I think that does it. Oh, no, another question. Nick Tambora, given the extensive background on use of Omega, what in general are you looking to modify? Oh, well, this is like a whole nother workshop all by itself. I think at our next workshop, we would be able to explain in more detail about exactly how we've modified it. And obviously all of those input files would be released as part of our rulemaking process too. So we're in the middle of still modifying things. So I think it's probably premature to just say what we're doing now. But I mean, I think the overall scope is trying to model our actual proposal, right? So that is hopefully helpful. Okay. Well, that's a wrap then for our second workshop. We'll see you sometime soon. Oh, my camera's off. We'll see you sometime in the fall. And we look forward to meeting with you. Just because this workshop was virtual, we do want to meet people in person. So please feel free to come and visit us either in the Riverside office or in our Sacramento headquarters. All right. Thank you very much. Have a good day, evening, whatever. Bye-bye.